Okay. My phone. Okay, so this is like the fourth time I am apologizing. You know, say you get as Nigeria day. We never did too much advanced. You get. So now why? Our connection they cut. But you know go cut it. Are they sure? This time around, it cut. Okay, so as I was saying, sorry, you know go cut again. So please, I'm so sorry, parents, children, everybody. We plead and ask that you bear with us. However, your 6 hours is still going to be there. I believe you're preparing for an exam, and I'm sure that after this class, your head will be fired up. That's what I'm sure of. Okay, let's get right into it for want of time. So I was talking about isotopy, and quickly, let's get right into it. So I said, if you look at the board, we have Cl1735, Cl1737. You will notice that the atomic numbers of these two atoms are the same thing. Why? Because what makes an element is the atomic number. So if you're talking about chlorine, chlorine must have an atomic number of 17. If you write Cl and write 18 here, this is not chlorine. This is argon. The reason is this. The periodic law states that the periodic functions of an atom or an element, the characteristics of every element is a periodic function of its atomic number. So if you have chlorine 18, Cl18 can never exist. Why? Chlorine can never have 17 protons. So have this in mind. The proton number can never change. Once it changes, it's a new element. However, what you will notice here that is changing is the atomic mass. Now, if I am to ask a question, the difference in the atomic mass is as a result of what? Listen. So let's have this in mind. If you are asked the difference in whatever causes isotopy, what is responsible for isotopy, is simply because there is a difference in atomic mass. But what causes the difference in atomic mass? Let's find that out. How many protons do you have here? 17. So if you have the atomic mass equals 17 plus neutrons, and the atomic mass here is 35, you would have 17 plus neutrons. Now, with that said, if we are to consider the number of neutrons, N is equals 35 minus 17. How many do we have here now? 18. In the case of chlorine 37, we have 37 is equals 17 plus N. Therefore, N will be equals 37 minus 17. So the number of neutrons is what? 20. Jam question. Which one of these particles is responsible for isotopy? Option A, difference in the number of protons. Option B, difference in the number of electrons. Option C, difference in the number of neutrons. What is the answer? C. So what causes the difference in the atomic mass is because the neutrons have a difference. In this case, you have 18. In this case, you have 20. That's settled. When you have two isotopes and you expected to resolve it, you have chlorine 35, you have chlorine 37. And the question comes, which one of these atoms should you use whenever you're doing your reaction? You can't just pick anyone. You will need to find something related to an average. Am I communicating? For instance, now, we go write jam. Your jam score, 320 in Jesus' name. Thank you. Your post-UTME score, something like 315. Now, you have 320 jam, 315 post-UTME. And the school is supposed to take you into the school or give you admission. Which one of the scores would they pick? Jam or post-UTME? Post-UTME? No, that's not what they do. Common sense also say so. What they do is that they merge it together and find what? An average. That's exactly what's going to happen here. So if you want to do a reaction, you have to pick one. How do you pick it? Add them together and then find what? An average. So let's continue. How do we now find the average? The average is referred to as relative atomic mass. So take note of this formula. Whenever you are asked to find relative atomic mass of isotopes, it is given by RAM equals. Now, before I continue, there are two major isotopic abundances used in chemistry. One of them is percentage, and the other one is ratio. You could see a question where isotopy has to do with percentage. You could also see a different question where isotopy has to do with what? With ratio. Okay. So you have RAM equals percentage 1 multiplied by atomic mass 1 plus percentage 2 multiplied by atomic mass 2 all over 100%. That's 100. So whenever you are asked to find relative atomic mass and you have different isotopes and you are supposed to find the relative atomic mass given percentage, the formula to be used is RAM equals percentage 1 times atomic mass 1 plus percentage 2 times atomic mass 2. Imagine you have a third one. What will it become? Plus percentage 3 times atomic mass 3. All over waiting 100. Oh yeah, put this down quickly. Put this down quickly. So let's take, for instance, we have a question. We have a question. So right, everybody. Question number 1. Question number 1. Question number 1. Question number 1, you write. Two isotopes of lithium. 2 isotopes of lithium are the 2 isotopes of lithium are lithium 4 and lithium 5. 2 isotopes of lithium are Li43, Li53 with respective percentage abundance of 75% and 25%. Respective percentage abundance of 75% and 25%. And the question is, what is the relative atomic mass? What is the relative atomic mass? Now, I'll solve this, then I'll give you a question to solve. So please listen. We have looked at the question. First of all, when you hear the term respective, it implies that the first element or atom will take the first value. The second one will take the second value. That is what respective implies. So it means that the first percentage will be for lithium 4. The second one will be for lithium 5. With that said, if we look at the question, we are asked to find the relative atomic mass of isotopes. And what we have there is percentage. There is a straightforward formula of solving this. And what is the formula? The relative atomic mass is equals what? Percentage 1 multiplied by atomic mass 1. Put it in brackets plus percentage 2 multiplied by atomic mass 2. Put it in a bracket. All of them, all over 100. So apply your values. We are looking for RAM, which is equals, what is the first percentage? 75%. Associated with what atomic mass? 4. What is the second percentage? 25 associated with what? 5. So all divided by 100. If you do this, yes, what is it going to be? 75 times 4 is how many? 300 plus 25 times 5, 125, all divided by what? 100. Now, if we are to take this down, what we are going to have, can you see? Can you see this? Okay, so you have 425 divided by 100. And what is our relative atomic mass? 4.25. So I hope this is clear. I hope this is clear. Okay, so with that said, let's try this one. Let's try this one. Hold on, let me get the questions. Okay, so you're right. Oxygen is a mixture of two isotopes. Oxygen is a mixture of two isotopes, O16 and O18. Oxygen is a mixture of two isotopes, O16 and O18. When I mean O16, I mean O with atomic mass of 16, O with atomic mass of 18. Then you are asked, oxygen is a mixture of two isotopes, O16 and O18, with relative abundances of 90% and 10%. With relative abundances of 90% and 10%, respectively. Remember I said something about respectively. It implies that the first value is for the first atom or element. The second value is for the second atom or element. Respectively, 90% and 10% respectively. Full stop. The relative atomic mass of oxygen is dash. Option A, 16.0. Option B, 16.2. Option C, 17.0. Option D, 18.0. So yes, solve. Answer gotten 16.2. Those online, can you give us your answers before we solve generally? Okay, so some of our answers, who said 16.2? The name is there speaking. So it, huh? Okay, so Mr. Beast, Eze Chidema, you are all correct. Once you said 16.2, 16.2 is correct. So let's solve it to show us how. Those in the live class, I hope this is also your answer. Okay, so let's solve it. First of all, is you are asked to find relative atomic mass, and you are dealing with percentage. So what is it going to be now? You have RAM equals what? Percentage 1. Let's just go on. We know the formula now. Percentage 1 times atomic mass 1 plus percentage 2 times atomic mass 2, all over 100. What is the first percentage? 90%, which is associated with what atomic mass? 16. Plus, what is the second percentage? 10%, which is associated with what? 18, all divided by 100. So if you do this, 90 times 60, what do we have? 1440 plus 180 divided by 100. What is this going to give us? 1620 divided by 100. And what is this? 16.2. Easy. Now, relative atomic mass does not have a unit. Yes. Relative atomic mass does not have what? A unit. Why? It is referred to as a dimensionless unit. When you say something is relative, you are looking at the proportion of something of a given unit to another value of the same unit. So if you have similar units or relative units, they cancel out. So it is referred to as a dimensionless quantity. So no units. Relative atomic mass does not have units because it is relative. You are relating the unit of a particular value to the unit of the same unit of another value. So it cancels out. That's why we have no unit for relative atomic mass. So our answer is option B. I hope this is understood. Now, try this before we get into the ratio relation. So put this down. You write, right, everybody? The relative atomic mass of chlorine, the relative atomic mass of chlorine, the relative atomic mass of chlorine is 35.5. Okay, before we even continue, I hope you know that if you are given the relative atomic mass, you can use the values to find the others. It's just simple, basic mathematics. I'm not your math teacher, but you should know this. Just substitute the values, do your cross multiplications, your divisions, your collecting like terms, you'll get your answer. So we are twisting the question a little bit. So right, the relative atomic mass of chlorine is what? 35.5. Full stop. Given that it is made up of two isotopes, Cl35, given that it is made up of two isotopes, Cl35 and Cl37. Cl35 and Cl37. Cl35 and Cl37. What is the relative abundance of the isotope of mass number 37? What is the relative abundance of the isotope of the mass number 37? What is the relative abundance of the isotope of mass number 37? So let's try it. The jump question. Let's try it, see how it goes. Okay, you have 30 seconds to solve that. I guess my 30 seconds is long gone. Do we have an answer in the hall? Live students? 25% online. Okay. Yes, live. What do you have? 25%. Now, let me just mention this. Listen, both those online and those live. Whenever you are dealing with chlorine, sometimes you don't need to solve. There are questions that you don't need to solve. Once you see chlorine, if they ask you relative atomic mass, just cram it now, 35.5. The percentage associated with chlorine 37 for the relative atomic mass to be 35.5 is always 25. So whenever you see chlorine 37, the percentage is always what? 25%. If you see chlorine 35, the percentage is always 75%. Have this in your head permanently. However, I will show you how it is being solved. So that I don't need to waste your time. Once you see Cl and they say relative atomic mass of Cl, you don't need to solve. It is 35.5 relative atomic mass with the isotopes Cl37 and Cl35. Am I communicating? Now, you now talk about Cl35. Cl35 has percentage abundance of 75% once the relative atomic mass is 35.5. And then finally, Cl37 has a percentage abundance of 25%. So let's get to how we solve this. Okay. So first of all, we are asked a percentage abundance. And because of that, we are going to be using RAM equals percentage 1 multiplied by atomic mass 1 plus percentage 2 multiplied by atomic mass 2, all divided by 100. Now, I would like to identify my variables and values before I start solving. Let's start with the relative atomic mass. It was given in the question. And the relative atomic mass in the question is what? 35.5. Were we given the percentage of the first isotope? No, we were not given any percentage, right? So the percentage of the first guy, let's call him X. Are we following? Atomic mass 1, was he given? Yes, what's the first guy? So atomic mass 1 is 35. Let's go to the next one. Percentage 2. Were we given percentage 2? No, we were not given any other percentage. Now, but have this in mind, that if, for instance, I tell you, you have green balls and orange balls inside a bag. You have 5 green balls. 5 green balls. Let's say, okay, I take it again. You have a particular container and you have 5 green balls. And then the total ball here is 15. How many blue balls do you have? Blue balls, how many? You have total is 15. The green balls are 5. The rest is how many? Now, how did you get it? The number of blue balls is equals the total number 15 minus the number of green balls. Now, let's come here. The total percentage is 100. What did I say is total percentage? Everybody's supposed to know this one now. Total percentage now waiting 100. Oh yeah, you have 100% minus the value of the other guy. What is the other guy's value? X. So anytime you are looking for percentage 2, it will be 100 minus X. Total percentage is 100 and total percentage is percentage 1 plus percentage 2. Which means that if you are looking for percentage 2, it is 100 minus percentage 1. What is percentage 1, class? X. So percentage 2 will be equals 100 minus X. Sorry, I hope I'm communicating with you. Good. Let's go on. What else are we given? Atomic mass 2. What is atomic mass 2? 37. What is atomic mass 2? 37. So with that said, let's apply these values and see if we'll get an answer. Let's apply these values and see if we'll get an answer. Okay, so applying it, you can go ahead and start applying it and see if your answer is going to be 25%. So let's continue. Where were we? Relative atomic mass is 35.5, which is equals, what is percentage 1? X multiplied by atomic mass 1, 35, plus what is percentage 2? 100 minus X. Now put this in a smaller bracket because these two values are joined together. So multiplied by what? 37, which is atomic mass 2, all divided by 100. Now, with this now, cross multiply, right? 100 times 35.5, we have 35.5 times 100 is going to be equals 35x plus, now this 37 is not just multiplying x, it is also not just multiplying 100. So it is going to multiply this value and also multiply that value. So have that in mind. So let's open the bracket. 37 times 100 is what? 3,700. 37 times minus x, minus 37x. Remember, with this now, we are going to now need to collect like terms. You have 35.5 times 100 is going to leave us with 3,550, which is equals, collecting like terms here, what do you have? 2x, right? This will be 35x minus 37x plus 3,700. We collect like terms. Collecting like terms means that the similar values will be on the same side. Similar values will be on the same side. The similar values here are 35x and 37x. Then this is the similar. So it has to go over. If a plus sign is crossing equal sign, class, what will it give us? Minus. So you will now have 3,550 minus 3,700 equals minus, what do you have? Minus 2x. Mathematics. Minus these two, what do you have? minus 150, which is equals minus 2x. According to your mathematics you learned in school, what should you do? Divide both sides by the coefficient of x. Coefficient of x, is it 2 or minus 2? 2 or minus 2. So divide by minus 2, divide by minus 2, plus plus 2, 2. This plus plus. So what do you have? 150, 75. So we found out that x is what? 75. Now, but that's not our answer. Let's come back. If you go back to your question, the question did not say the percentage abundance of chlorine 35. It said percentage abundance of chlorine 37. X is the percentage for chlorine 35. If we are now looking for percentage of chlorine 37, it is now going to be percentage 2 equals 100 minus x, which is going to be equals 100 minus, what is our x in this case? 75. The 75 we got was x, and x is for 35. Percentage 1 atomic mass 1. 75 is for 35. So if we are looking for percentage 2, which is associated with 37, it will now be 100 minus x. 100 minus 75 is what? 25. And you have your answer. As I said, the only reason it's taking this time is because I'm teaching it. And as I was solving, I was illustrating. However, it's not going to take you this much time. But I've mentioned this and I'm saying it again. Once you get into the exam hall and you see chlorine, constant, 35.5 relative atomic mass, once you have 35 and 37, percentage abundance of 35 is usually 75 if the relative atomic mass is 35.5. And then finally, 25% if the relative atomic mass is 35.5. Okay, put that down. Are we writing this? Okay, I'll give you guys 20 seconds. Those online, 20 seconds to put this down. Okay, I presume you're done with this. Let me say it again. Those that just joined us, if you are streaming at 720 pixels, I advise that you reduce it. You can still see the board and me. Even if you're not seeing me, the most important is that you're seeing the board. Clearly, at 360, 420 megapixels is okay. Don't go above that. You know our slogan for that. You might see me clearly with 720 and 180, but your data will finish early. Let's continue. So I guess you're done with this. Now, you know, I mentioned earlier on that there are two. Yeah, someone said they did not understand. We would repost the video in the group. And if you still do not understand, I will have to step in the group. You get what I'm saying? And besides that, you know, you can drag it backward so that you will check what I said. Probably you did not understand because you missed one of the things I said. So you can go back and then come forward. However, if you go back, we are moving forward. So let's continue. Now, it's just for want of time. I would have re-explained, but for want of time. So just try to understand this next one now. I've forgotten her name. Was it Chidima or something? So please bear with us. We would happen to try to re-explain with this next example. So just listen. So one of the other reasons, that might prevent you from understanding what was said is if you have a basic mathematics problem, and that basic mathematics problem will not be resolved in my chemistry class. So have that in mind. Now, with that said, the second isotopic abundance is referred to as ratio. The second isotopic abundance is referred to as ratio. And that Mona know they distract me now. Mona life class people. Sorry, online people don't mind these ones. They are joking with their lives. So as I was saying, ratio. The first one a percentage, second one a weighting ratio. So if you are giving ratio, we know what ratio is now. 1:2, 2:3, 1,000 is to teacher is to, and so on. $1 billion is to my name in Jesus' name. Amen. It no be my fault. Oh yeah, all you did here. All you did here, more the clean board well. You know, say ink now organic. Where water dey? Oh yeah. Oh, the cleaner. Water. No be my fault. Oh yeah, who go bring container for us? Sorry, more clean board where? Goes online. So unto the Lord. Quincy, oh yeah, this side. Don't apply water here. Human being where name be Quincy. Sorry. I hope we did not do a good job, but we're going to manage small. Oh yeah, where we did? So, bros, you're gonna be sitting close to me. You're gonna be my butt cleaner. You fresh. You understand? You fresh for video. No worry. They know they complain. Share online people. May we continue. Vote Quincy for butt cleaner online. Quincy, is it a go? If it's a go, say it's a go. Quincy is a go. If not, let's continue. We should select another person. Let's continue. Now, I said that there are two methods, percentage and ratio. Percentage is done. The next one is ratio. Now, see ratio here. RAM is equals, listen, ratio 1 multiplied by atomic mass 1 plus ratio 2. Is that easy, Sha? Ratio 2 multiplied by what? Atomic mass 2. All of them. Now, remember when we did percentage, we divided by the total percentage, which is 100. This time around, we are going to divide by the total ratio. What is the total ratio? R1 plus R2. Imagine there was a third ratio. What will it now be? R1 plus R2 plus R3. If there was a fourth isotopic abundance, what will it now become? R1 plus R2 plus R3 plus R. But we're not dealing with that, so let's use this. Am I communicating? So put that down. Quickly. Be fast about it. So with this now, solve this question. I don't need to, I would explain after you try it out, but try this question out. So everybody writes. Chlorine consists of 2 isotopes. Chlorine consists of 2 isotopes. Chlorine consists of 2 isotopes of mass number 35 and 37. of mass numbers 35 and 37. Of mass numbers 35 and 37. In the ratio 3:1. In the ratio 3:1. In the ratio 3:1. Are we there? Full stop. You're now right. What is the relative atomic mass of chlorine? What is the relative atomic mass of chlorine? This one follow for question, Seth. Mona solve, Jare. We have gotten the answer. I told you once you see 35 and 37, what's your answer? But solve it. Still solve. Make I see what I want to. Oh yeah. Camera, capture this person. Show her book. Show her face and her book. Or show her book. Yes. So that we'll see what we are doing here. Online people, now don't get answer, ba? 35.5. Who got that answer? Emanuela, correct? If like I go do giveaway today, what do you think? Mr. Beast, you are doing well. I've seen you how many times? Make I do giveaway. Make I do giveaway. It's all right. So I hope we got that. Now let's solve it. Let's solve it. It's common sense. For want of time. So I will leave Isotope and go to something else. Now, we are looking for the relative atomic mass. Were we giving ratios? Were you giving the ratios? What are the ratios? 3:1. Now, once you see that, it means that first atomic mass will take the first number, second atomic mass will take the second number. So what do you have? RAM is equals. What is R1? What's R1? 3 times, what is the atomic mass 1? 35 plus, what is R2? 1, atomic mass 2, 37, all over. What do we have now? 3 plus 1. So what is this going to give us? Oh yeah, 3 times 35, 105 plus 37, all over waiting 4, which is going to leave us with what now? 142 divided by 4, and that is going to give us 35.5. This is not a hard thing. Chemistry is easy. Very simple. Is this one not easy? It's easy. And this is the one you see. The one that is hard, it will not come out. Don't worry. So the major logo for this class is 90/100 in chemistry or nothing. What did I say? If you no get 90, maybe your result no go show. How do you think? So 90 or nothing, we must see that 90. You understand? So let's continue. Now, we are done with that. Empirical formula. Those online, should we talk about it? I just need 5 yeses or 5 no's so that we'll move ahead. Empirical formula, the live class students said no. We also want to know what you have to say. Empirical formula, 5 yeses and then we do it. 5 no's and then we don't. Media, what do we have? Empirical formula, yeses or noses. Whoa. You're getting 1 no, 2 no's, 3 yes, 4 yes, 2 more no's, which is complete, right? Is it not 5? So, yes, pass no now. Sorry, yes, pass no, but it will be simple. Now, listen. Empirical formula is the simplest formula of a particular chemical compound. Please, let's listen. I'm going to just do it in 15 minutes. So listen. Empirical formula is the simplest chemical formula. Is the simplest chemical formula of a compound. The implication is that the simplest possible formula a compound can have is referred to as what? Empirical formula. Now listen. it only tells us about the ratio of atoms. It doesn't indicate the actual number of atoms. I take it again. Empirical formula is the simplest chemical formula. All right, everybody. Empirical formula, quickly, just definition, we move ahead. Empirical formula is defined as the simplest chemical formula which indicates the ratio. Empirical formula is defined as the simplest chemical formula which indicates the ratio. Simplest chemical formula which indicates the ratio of atoms. Indicates what? The ratio of atoms. Indicates the ratio of atoms in one molecule of a compound. In one molecule of a compound. Indicates the ratio of atoms in one molecule of a compound. So it doesn't necessarily tell us the actual number. All it does is that it tells us a ratio. For instance, now, the empirical formula of your benzene is CH. But please, in benzene, do you have one carbon and one hydrogen? No. It only tells you the ratio. It doesn't give you the exact number. The formula that will give you the exact number is molecular formula. All right, now, let's take down rules. All right, rules for determining empirical formula, quickly. Rules will solve 2 questions and then we are done. Okay, now take note of this. If you have a question on anything we discussed, it is important that you take note of it. We'll be opening the group at a particular point to accept questions. I take it again. If you have questions on anything we discussed, maybe you saw a JAM question, take note of it. We'll be opening the group just for questions, not for complaints. Now, uncle, my phone is upside down. I cannot see you. I don't take nonsense. I will remove you from here and the group. Once, as I was saying, if you have questions concerning what was discussed, take note of it and send it to the group if and when it is opened. We will answer all your questions. If you want us to use video, answer you, no problem. But for now, let's just be taking note. Our rules. Rule number 1. The first rule in solving empirical formula is identify, rule number 1, identify the constituent elements in the compound. Rule number 1, identify the constituent elements in the compound. Identify the constituent elements in the compound. Number 2, identify, rule number 2, identify their relative abundances. Identify their relative abundances. Okay, what do I mean by that? Okay, another way of saying it is identify the mass composition or percentage composition of the constituent elements. Number 2, identify the mass composition or percentage compositions of the constituent elements. Those values are going to be given in the question, so don't worry. Identify the mass compositions or percentage compositions of the constituent elements. Okay, are we done with that? Yes, we move to rule number 3. Rule number 3. Divide the respective percentage composition or mass composition. Divide the respective percentage composition or mass composition by corresponding relative atomic masses of the elements. Divide the respective percentage composition or mass composition by weighting corresponding relative atomic masses of the elements. Divide the respective mass compositions or percentage compositions by corresponding relative atomic masses of the elements. Now, when I say that, did you hear me mention relative molecular mass? No, I said relative atomic mass. So you are considering one atom. If you have Cl2, the relative molecular mass of Cl2 is 71. The relative atomic mass is 35.5. People that have sense, that their village people are not working in their head. Are you using 71, which is the molecular mass, or the 35.5, which is the atomic mass? Which one of them? 35.5. I beg you in the name of God, may your village people not speak to you in Jesus' name. Let's continue. So you are dividing by the atomic masses, not dividing by the atomic masses. This is relative molecular mass. Is a no. This is relative atomic mass. What did we give it? Is a go, which is a yes. So let's continue. Make her the right this side. Okay. So we go the right this side. Make her the shift. I know the sorry, how did my engineer? They are, who you the points now? Okay, let's continue. Now, as I was saying, I presume we are seeing what I'm doing. So rule number waiting within now, number 3, not 4. Okay, we go to the next rule. Now, after that, divide all the values gotten from rule 4 above. Is it rule 4? Rule 3 above, yeah. Divide all the values gotten from rule 3 above. Divide all the values gotten from rule 3 where above by the smallest value amongst them. Divide all the values gotten in rule 3 above by the smallest value among them. Divide all the values gotten in rule 3 above by the smallest value among them. So the implication is that you will check for the smallest value. I don't know how some people's village people used to work, but you will see something like 1.3, and you will see something like 0.31. Between these two values, which one is smaller? Is it 1 point or 0.31? Because some of you will not be like, uncle, but 3 is bigger than 1. Have sense in Jesus' name. Before 3, what do you have? 0. Am I communicating? So have that in mind, that you are dividing by the smallest value amongst them. Then finally, I think that should be finally, the value gotten from that particular answer is the ratio that gives us what? The empirical formula. Am I communicating? So what did I say is rule 4 finally, before I get to the last part? What's rule 4? No, rule 4. Values gotten from rule 3 above should be divided by the smallest value among them. Now, that is that, and whatever answer you have there is going to be used to form your relative, your empirical formula. So I take it again. Rule 1, identify the constituent elements. Rule 2, identify the mass composition or percentage composition. Rule 3, divide the percentage of mass composition by their corresponding atomic masses. And then after you are done with that, the smallest value among them will be used to divide everybody. And your final answer is what determines your empirical formula. With that said, there are certain notes that you must take. You will not find these notes in most of your textbooks. I'm not even sure you see it anywhere. So write it. That's why you are in this class. If the final values gotten from rule 4, if the final values gotten from rule 4 are 0.5 decimals, if the final values gotten from rule 4 are 0.5 decimals. When I say 0.5 decimals, I mean you have 0.5, 1.5, 2.5, 3.5, 70.5, anything 0.5. Once you notice a 0.5 decimal, do not approximate. What did I say? Do not approximate. So if if the final values or any of the final values gotten in rule 4 is a 0.5 what decimal, multiply all the values by 2. Multiply all the values by how many? 2. If the final values you are getting is a 0.5 or any, sorry, I meant if any of the final values gotten, any of them. It doesn't have to be all of them. If any of them is a 0.5 value, you multiply everybody by how many? By 2. Second NB. Second NB. Nota bene, right? I mean, nota bien. I don't know. So, second nota bene, you write, if any of the final values gotten, if any of the final values gotten is a 0.333 or 0.667, if any of the final values gotten is a 0.333 or 0.667 value, if any of the final values gotten is a 0.333 or 0.667 value, multiply all the values by 3. If any of the final values gotten is a 0.333 or 0.666 decimal, you have to multiply everybody. What did I say? Multiply what? Everybody by what? By 3. Every of the values gotten there should be multiplied by how many? 3. We move ahead to the next one. Now, with that said, I think at this point we can solve 1 or 2 questions. Okay, so right. Question number 1. I have not gotten it, so please hold on. But if you have the answer, can you tell us the answer to question number 1? Option A, bar. Option A. If this thing enter, I promise you big Zobo. If this thing enter, option what? What is the answer? Option D. If this answer is option D, big Zobo. Okay, when I want to just call A, B, C, D, forget about it. You know, that's actually true. Please listen. Do not leave any option blank, because you have a 25% chance of getting the answer. But after the class, you are going to have a 100% chance of getting what? The answer. Oh yeah, let's solve this thing. Very simple question. The question says, an organic compound containing 40.1% carbon. An organic compound containing 40.1% carbon, 6.67% hydrogen, 6.67% hydrogen, 6.67% hydrogen, and the rest is oxygen. And the rest is oxygen. Has an empirical formula of dash. Has an empirical formula of dash. So let's just check it out and see what we have. The options given here. Option A, C2H4O2. Option B, C2H3O2. Option C, CH2O. Option D, CH3O. Now we're going to solve this. Now listen. Oh, summer. We are going to follow the rules. And once you follow these rules, you can never fail anything. What did I say will happen? You can never fail any question. Okay. So with that said, let's move on. Okay. So let's get to work. What is rule number 1? Let's read it. Identify the constituent compound. So let's look at our question. Question read. Want to read it? Go. Yes. Organic compound contains, what is the first compound you're seeing? First compound is carbon, right? Next compound, hydrogen. And the rest is what? Oxygen. Let's continue. Yes. So the second rule, what's the second rule? What's the second rule? identify the mass compositions, right? Or percentage. Which one did they give us? Mass or percentage? Percentage composition. So what is the percentage composition of carbon? 40.1%. That of hydrogen is what? 6.6%. And oxygen is the rest. Okay? What is oxygen? The rest. Now, earlier on, we noted something. Let's go to a side note. That the sum of percentage is how many? 100%. So that means if I'm looking for the total percentage, 100 will be equals 40.1 plus 6.6 plus the rest. Abi, we are looking for the rest. But the rest is now going to be equals what? Okay, before that, this is 100 equals, add these two. What do you have? 46.7 plus the rest, right? So 100 minus 46.7 is going to give us the rest. So what is our the rest value now? 53.23%. So when we are looking for oxygen, we added everybody, it should give us 100. If you add your percentage composition of the constituents and it doesn't give you 100%, when you're doing a percentage, it means that somebody is missing. If you add these two, what you have is 46.7. So for us to get the total percentage, it must give us 100. And with this guy missing, we have to find him. It's mathematics. So with that, what is our the rest value? 53.23. The rest value is what? 53.23. Oh yeah, let's go to the next rule. What does the next rule say? Divide what? The don't we have the rule? Divide them respectively by their what? Corresponding relative atomic masses, right? Atomic masses, I meant to say. Now, what is the atomic mass of carbon? 12, H is what? 1, O is 16. So here, what do we divide by? What do we divide by? And then here, what do we divide by? 16. Oh yeah, let's go. 40.1 over 12. 3.34. 6.6. What do you have? Yes, divide. 3.33. Now let's look at the board. We have 3 values. And what is our final step? Divide by the smallest. 3.34, 6.6, 3.33. What is the smallest value? So this divided by 3.33, divided by 3.33, divided by 3.33. Class, what do you have? 1.60. 3.34 divided by 3.33. 1.0 something, right? Because it is 0. We don't have any special thing. Approximate is 1. What do you have? 2.0, which is what? 2. What do you have? 1. So please, our empirical formula is going to have how many carbon? 1 carbon. How many hydrogen? 2 hydrogens. And how many oxygen? 1 oxygen. So what's your answer? CH2O, which is option what now? C. Who said C before? It's A and D, you said. Online, I'm sure. Who said C? You said C? Online, I hope people did not say C. Now, do you talk, so? Let's continue. Don't worry, I will give you big Zobo on the 31st of April. Okay, don't pass. Sorry. Let's continue. Okay, so are we there? Good. I hope this is understood. I'll give you time to write this down. So put this down quickly. Put this down quickly. You have 30 seconds to solve. Put this down. Then you solve this one. Okay. Now let's solve this one. Everybody, write. Everybody, write. A hydrocarbon containing 88.9% carbon. A hydrocarbon containing 88.9% carbon. A hydrocarbon containing 88.9% carbon has the empirical formula of dash. A hydrocarbon containing 88.9% carbon has the empirical formula of dash. Now, before you start solving, when you hear, we had a class yesterday, an organic class, and in the organic class, we said that organic compounds are classified into two, hydrocarbons and non-hydrocarbons. Hydrocarbon contains only two elements. What are those elements? Hydrogen and carbon. Common sense, hydrocarbon. So hydrogen and carbon. They gave you the percentage of carbon. Can you find the percentage of hydrogen based on what we did? It's common sense now. So solve. Everybody, give me an answer. First person to get it online. How much card I won't give you now? First answer don't enter. Online. Okay, make a right option. Eh? Yes, yes, yes. Options. I will get those stuff, huh? Yes. Option A. Option A is CH. Option B is CH2. Option C is C2H3. Option D. Somebody has said C. CH2. B. C2H3. Which one do we take? C2H3. So that's the first person that says C2H3, right? Did I promise anything, please? Mr. Beast said C2H3. I don't promise anything, no. I beg. I promise anything? No. So let's continue. Let's solve this. Wait now. You hear me when I promise anything. Wait first. What will solve? I will never forget that my experience. I have learned from my experience. CH. Sequence. CH. Oh God. Hope you have sense. Sorry. You don't get sense, huh? Let's continue. Now, first of all, is please, for now, you are going to go back on your own and solve questions. And while you are solving questions, please listen. You are supposed to be using these rules. Just use these rules as you are solving. Use these rules as you are doing what? You are solving. Don't try to solve it independent of the rules for now. What did I say? As you are solving, just be looking at the rules, following the steps, basically to help us or help you until you are sure you are used to them. I keep saying this. If you try the first time, you fail, you don't understand. What do? You read it again. If you tell it the second time, you don't understand, you come and meet me, if you know me, or meet your classmates first. If you meet your classmate, he explained, you don't understand, you meet me. After you meet me, you don't understand, we'll go to God in what? In prayers. But then I've always told you guys that if you want it to enter your head, read it for 1,565 times. If you read this rule for 1,500, and if you don't enter your head, hey, make I bend. Make I feel bend. That's what I mean. You get? Or make another person leg bend. Let's continue. Now, as I was saying, let's solve this question. First rule, class, what is the first rule? Identify the constituent. They go tell you. And what are the constituent elements here? Hydrocarbon. Hydrogen and carbon. Carbon and hydrogen. We are done with that. The next thing is to identify what? The relative abundance, right? Percentage composition. What's the percentage composition here? It's 8.9. That means here will be 100 minus 88.9, right? What is it? 11.1. Now, are we saying this? Now, what is the next rule? Divide it by what? Who is jumping rule? Rule number 2. Divide by their corresponding relative atomic masses. Here is 12. Here is 1. It's 8.9 divided by 12 is what? 7.4. 11 divided by 11.1, 11.1. Shall we know? So what are we dividing by? 11.1 or 7.4? By the smallest. People's village people might remove this point and put it here. I know you are here. You are seeing me. But all these village people, okay, he's even physically here. Yeah, so we have one. His village people are very, that boy that cleaned the board. His village, where are you from? Your village people are very strong. You understand? If you like say your mama's side or your papa's side, they are putting us together. I beg. Jam is something spiritual. I'll keep telling you guys, I had an experience where one of those years I was writing, I entered the exam hall. I started solving. If I talk answer, I go talk for my mind. I know will click the answer. I will click next. I will say the answer in my head. What will I do after that? Next. I did this almost all throughout the exam and finished. I had like 15 minutes or 20 minutes remaining. But then I was seeing space everywhere. I was not like waiting the happen. Say I don't finish the exam. And I went back. And I saw that what I was doing was say the answer next. Say the answer next. It shall not be your portion in Jesus' name. Let's continue. Now, divide this. What do we have? Divided by smallest value, 7.4. 7.4 bar. 7.4 bar. Oh yeah, what do we have? 1 is to what? 1.5. Some of you are going to take this as your answer. And be like, uncle now, approximate, okay? Yes. 1 is to 2. Wrong. Go back to your NB. Everybody. What is our NB? Can we read our nota bene? If any of the final values gotten a 0.5, are you seeing a 0.5 decimal here? What should you do? Is that what I said? I did not say multiply by 2. I said multiply all the values by what? 2. People's village people here are very strong. See what they will do to you. You will multiply this one and leave this one. Or you multiply this one and leave this one. Please, you are multiplying all the values by what? By 2. So this is multiplied by 2. 2 times 1 is 2. 2 times 1.5, 3. So what is our empirical formula now? Carbon 2. Hydrogen, how many? So final answer. What is it? C2H3. What is the option here? C. Ofialaro. Let's continue. So put that down. Put that down. I'll give you opportunity to write this down quickly. So option C. Option C. Oh yeah. Well, let me stop there for empirical formula because I'm getting to molecular formula for want of time. Solve questions. Remember, the group is going to be open. I wanted to close the group immediately after the class, but we'll leave it there till jam. Once you have a question on what we discussed, send it to the group. We will respond. I will respond in such a way that you will fully understand. Now, moving ahead. Board cleaner. Okay. Don't worry. Don't worry. Make I clean board. Online, when I don't write finish. Physical class, when I don't write finish. Online. Is the board they go? They don't. Wait. They never write. Shade they don't. Mona to time no day. I just simple thing. Eh? Oh, yeah. So this is the young man I was talking about. That his village people are working coherently. Jesus Christ. This was People will not get sense of this word, they many. They many. You go announce your jam score for our YouTube. After the exam. Oh, but cleaner. Finish everything now. Okay. Now, I said that empirical formula tells you ratio, but molecular formula will give you actuals. Empirical formula will tell you ratios. Molecular formula will give you actuals. So, if you are to define molecular formula, you write, molecular formula is the simplest chemical formula which indicates the actual number. Okay, I should take it again. Molecular formula is defined as the simplest chemical formula, which indicates the actual number of elements in one molecule of a compound. Simplest chemical formula which indicates the actual number of elements. The actual number of elements in one molecule of a compound. So have this in mind. Empirical will give you ratio. The one that will give you the exact or actual is molecular formula. And how do we find it? Very simple. So look at this. If, for instance, you are trying to relate this, how do you get it? Empirical formula multiplied by n is equals, make sure they write this in full. Please listen. Empirical formula bracket n is equals molecular formula. Empirical formula bracket n is equals molecular formula. So the question is, if you are looking for the molecular formula, all you need is empirical formula and the next one is n. How do you find n? Very simple. N is equals molecular mass all over empirical mass. I take it again. What did I say is n? Okay, make I write this in full, I beg. M. Let's say molar mass. Let's use molecular mass. Molecular mass all over waiting empirical mass. If you are trying to find the empirical formula, just multiply the, if you're trying to find the molecular formula, multiply the empirical formula by n, and you get your answer. However, what is n? Molecular mass all over empirical mass. Okay, so put this down. I'm taking it out in 5, 4, 3, 2, and 1. So let's continue. Now, with that said, I will show you how to get the molecular mass and the empirical mass. That will not be an issue. Let's solve a question to be able to identify those things. Now, right. The empirical formula of a compound, is CH2O. The empirical formula of a compound is CH2O. The empirical formula of a compound is CH2O. Given that the molar mass of the compound, is 90, given that the molar mass of the compound is 90, given that the molar mass of the compound is 90, what is the molecular formula? Given that the molar mass of the compound is what? 90. What is the molecular formula? So don't worry, they must give you molar mass. If they don't give you molar mass, they will give you what they call vapor density. I'll talk about that after this. Well, let me solve this question just to help us understand. Now, C is equals 12. O is 16. H is equals what? 1. So let's get to solve this question. First of all, is you've been given your empirical formula. So in this question, you don't need to find it. However, there are some questions you'll be given where you need to find empirical formula. We have resolved how to solve that. Now, with that said, you talk about finding molecular formula when you have your empirical formula. And can I ask, in this question, do you have your empirical formula? Yes. So it's going to be easier to solve. May I remove this from the board? So if you are asked to find MF, it is equals EF multiplied by N. The implication is that the molecular formula, according to the question, what is our empirical formula here? CH2O multiplied by N. But class, do you know what N is? No. So we need to find N. How do you find N? N is equals molar mass divided by empirical mass. According to your question, were you given the molecular mass? Check. Go back to your question. You are given the molecular mass. Okay, if we read the question, it says, what does it say? Can we read it? The empirical is what's it going to happen? What is the molecular formula? So they gave us the molar mass as 90. The molar mass as what? 90. So you will do 90 divided by. Now the empirical mass is gotten from the empirical formula. How do you get the empirical mass? You add the individual atomic masses of the empirical formula. So that means, I take it again. How do you get the empirical mass? If you look at the empirical formula, you have carbon, 2 hydrogen, 1 oxygen. Just add their individual masses. You will get what we call the empirical mass. Empirical mass. How do you get it? What is C? 12. What is H? H is 1. According to what I gave you now, H is what? For how many of them are there? 2 plus O, which is what? 16. If you add all these things, you are going to have 90 divided by 12 plus 2. 12 plus 2, 14. 14 plus 16, 30. So what is this going to be? 0 cancel 0, 3 here 1, 3 here what? 3. So what is N? That means N is equals 3. Now that you have gotten N, all you need to do is to impute it in this particular relation. MF is equals what? CH2O. What is our N now? Times 3. So what is going to be our molecular formula? C3H6O3. And that's the answer. So put that down. Put that down. Quickly. Put that down. Those online, if you are following, please say yes. If not, say no, so that we'll know places we need to retouch. You can actually put out questions that I may or may not answer now. Just comments on what we just did, not full question. Just maybe, uncle, what did you say about empirical mass again? Uncle, blah 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 blah. Godson, where this one come from? Hey, oh, sorry, let me clarify. MF, write it in full. Sorry, is not. It is molecular formula. It's not mountain of fire. I know I'm saying this. Molecular formula. This is not evangelical fire, whatever. Is I know why they talk this thing. I've jammed students in my life. Any is gotten by this. This molar mass. This is why I know why they talk. I've seen this happen before. Uncle, what is MF again? I've said it before. MF is molecular formula. EF is empirical formula. So put this down quickly. We done? I guess we are done. So you guys, before I give you your own to solve, just listen. Some of the questions you will see will not have molecular mass given. You will have what we call vapor density given. When you are given vapor density, you are supposed to convert it to molecular mass before you solve. And that's very simple. Very, very simple. Now, it is as simple as ABCD. ABCD is not simple. Yeah, it's actually true. Because, oh yeah, if I ask this class now to read ABCD, I'm sure somebody will miss it. M-O-M-O-M-O-P. I never. For instance, national anthem is easy, right? I am sure some of us have forgotten the national anthem. If you want to prove it on your own, just try singing it. Arise, so come. It's not I forgot it though. It's just that calm down. So molar mass is equals vapor density times 2. Put this down. Those online, those on live, I don't even know what I'm saying, but just put it down. That molar mass is equals vapor density times 2. Molar mass 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 equals weighting, vapor density. So if JAM do mistake, no be mistake, sorry. If JAM by any chance give you vapor density, don't say, ha, this way are talking rubbish, so it's not what Godson said. That's not it. If they give you vapor density, what are you supposed to do to it? Multiply it by 2 before you start solving. So, see question. Imagine I told you, oh yeah, just help me out here. Vapor density is equals 13. What is the molar mass? Absence. Vapor density is 13. What is molar mass? 26. Oh yeah, watch it. How did I get it? MM is equals vapor density, which is 13 times 2. What do you have? 26. Oh yeah, live class. What if it is 12? Online, join us. If vapor density is 12, what is the molar mass? If vapor density is 11, what is the molar mass? If vapor density is 2, what's the molar mass? If vapor density is 37, what's the molar mass? No. Yes. That one who could have. Ha! So, I said if oh God. What's all this? I said 37 now. Vapor density is 37. What do you have? After I don't use calculator by the side. No, you were stalling. You're like, what did you say? I'm like, okay, let's continue. But hope that is clear. Once they give you vapor density, multiply it by 2, you will get molar mass. Oh yeah, solve this question. I don't even need to solve myself, but help me out. I have a question. Don't take it personal. Let's continue. Okay, guys. Hold on. Yeah. Sorry, I won't find the right question. Okay. So you're right. A hydrocarbon has an empirical formula of CH. A hydrocarbon has an empirical formula of CH, right? A hydrocarbon has an empirical formula of CH. CH as in carbon CH. The empirical formula is what? CH. So just C and H. A hydrocarbon has an empirical formula of CH. A hydrocarbon has an empirical formula of CH. A hydrocarbon has an empirical formula of CH. A hydrocarbon has an empirical formula of CH and a vapor density of 39 and a vapor density of 39. Full stop. Determine its molecular formula. Determine its molecular formula. A hydrocarbon has an empirical formula of CH and a vapor density of 39. Determine its molecular formula. Okay. Option A, C2H6. Option B, C3H8. Option C, C3H4. Option D, C6H6. What is our answer? Those on live, I don't know what I'm saying, but those here said it's D. Online, what's our answer? Is there any answer yet? I go count 15. Yes, option A, B, C, D. C6H6 from? Ugochi Emanuela, shout out to you. You are going to get a score. I see a score for you. I see a score for you. 3. Your score is going to start from 3. 1, 2. Abi, should I switch numbers? Somebody said C39H39. And the guy has a beastly name. Okay. Okay, so 312, 123, 231, 321. Y'all pick anyone. Option A, B, C, or D. I see something. Anybody that picked D, this is your score. In Jesus' name. Oh yeah, let's continue. Okay, you picked D. Okay. Even though that picked C, your normal answer was C. But that guy that picked that C39, A39. I don't want to say missing jam score, but let's continue. Quite simple. Now, how do we solve it? How do we solve it? Listen. If you are given a question, you need your molecular mass. But what they gave is vapor density. So first of all, convert the vapor density. How do you get it? Molar mass equals vapor density times 2. So what do you have? What is the vapor density? 39 times 2. What is it going to give us? 78, right? Let's get to work. Molecular formula is equals empirical formula bracket N, which implies that molecular formula is equals, what is the empirical formula according to the question? CH bracket N. Class, do you know what N is? No. But can we find N? How do you find N? N is equals molar mass all over empirical mass. What is N going to be? Molar mass is what? According to what we just did? 78. And then our empirical mass is CH, which is 12 plus 1, which is equal 78 over 13. And if you do that, we should have 6. If N is equal 6, the molecular formula is equals CH bracket 6, which means molecular formula is equal C6H6. Okay, I presume we all have gotten this at this point, so we're going to move to the next one. The next one is gas laws. Very important. Now, gas laws is one of the simplest part of chemistry, but it come out every year. Waiting I talk, it come out waiting every year. So get sense now, grab this thing. Class, don't be hot. Class, don't they do waiting, don't they hot. Grab it as it is hot. I'm gonna write. Those who they write, I'm gonna write. Have you finished writing? Right. Have you finished writing? Sorry, you. Are you done writing? They do fast, quickly. Wait, board, come on, clean this board properly. Be fast about it. As they claim and they claim terrible jam score from your life in Jesus' name. We will not see you writing jam ever again. They clean away 120. You are cleaning away 130. You are cleaning away 140. Even 210, you know go get your score. See how they laugh, they clean this thing. You just say you get any answer for all this. So you are smiling and cleaning. Your score, I see a number. But that number is a fraction. It's a fraction that can turn into a whole number. Let's continue. Okay. Should I call the number? It starts with, let me not say it now. It will start with the next answer you're going to get. So don't get a high number. Now listen, guys. When you talk about gas laws, there are 9 of them. Now, it's not your content. I'm not going to be explaining everything. So, first of all is this. When you talk about gases, first of all is this. When you talk about what? Gases. A gas is not a substance. It is a state. There are 4. Let's say 4. You know, normally we know 3. But there are 4 states of matter. There's solid, there's liquid, there's gas. And then there's an extra one called plasma. Plasma is the extra guy. Now, plasma is gaseous state which contains an appreciable amount of electric charge. Once a gaseous state contains electric charge, it is no more gaseous state. It is now what? Plasma. A substance existing in gaseous state which contains electric charges. You can't refer to them as gases now. They are referred to as what now? Plasma. A very good example. If you've noticed, some of our televisions, in front of the television, you get as you go take leave them on. If you come to the front of the screen, it will begin to waiting, shake you. It will begin to waiting. That shock you where they shock you. It means that it is no more gas that is there. I don't know whether it's why they call it plasma TV. It's possible. But the point is that the air around there has accumulated electric charge, so it's no more gas. It's now what? Plasma. If thunder strike you people, sorry, thunder will not strike you in Jesus' name. Let's say you have a thunder or lightning strike. Are we listening? The air around that area would actually have electric charges. And those electric charges, an air or gaseous state which has accumulated electric charge, is referred to as what? Plasma. What is it referred to as? Plasma. Oh yeah, let's continue. Now, with that said, I talked about the gas. And the gaseous state is very important because it has one of the special properties. For instance, the gaseous state has the weakest intermolecular forces between its atoms. If you notice, solid are held together. Liquids have a little bit of that's to say they are more that is they are held together, but not as much as the gases. But then when you talk about the gases the gases are completely set free. They are wild. They have the ability to spread. And because of that, we're going to be talking about some laws. Now, before we even move further, first of all, there are 4 quantities that are used to measure or quantify a gas. How many quantities? 4 quantities. Number 1 is volume. When you talk about volume is the space occupied by a gas. What did I say volume is? The space occupied by a gas. Volume is the space occupied by a gas. Number 1 is volume. It is the space what? Occupied by a gas. And when you talk about volume, volume can be measured. The units of volume are anything cube. So cm cube, dm cube, meter cube, centiliter, liter. So any of these guys are the popular ones we use in chemistry. Now, I will show you the relationship between them so that just in case you have that volume in cm cube is equals volume in dm cube times 1000. So people that have sense will know that volume in dm cube is going to be volume in cm cube over what? 1000. Put this down. Relationship between volume units. It's important to start knowing this thing because some of the times your values will be given in cm cube and you're expected to convert it to dm cube. So you simply do that with this formula. Volume in cm cube is equals volume in dm cube times 1000. Volume in cm cube is equals volume in dm cube times 1000. But what if you are converting cm cube to dm cube? Volume in dm cube is equals volume in cm cube all over 1000. Now, with this mentioned, are we listening? We go to the next one. Volume in dm cube is equals volume in liters. So when somebody says 1 liter, the person exactly means 1 dm cube. Volume in dm cube is equals volume in liter. If you say 1 dm cube, what do you mean? 1 liter. Okay, a little test of knowledge. Everybody, convert 50 cm cube of oxygen to dm cube. Online, those physically here, convert 50 cm cube, right, of oxygen to what? dm cube. 50 cm cube of oxygen to dm cube. Are we done with that? 0 point waiting. So those online, we are waiting for your answer. Those on live say that it is 0.05. Those online, what is your answer? Do I have an answer yet? Gang. Okay. Let's move ahead. Okay. 0.05 what, class? dm cube. So let's go. Ahead. Now watch this. We are converting to dm cube, right? Which formula is to dm cube? V in dm cube is equals the value in cm cube divided by 1000. Look at this. Were you giving your value in cm cube? Were you giving your value in cm cube? What is the value? 50 cm cube divided by 1000. Once you do that, your value in dm cube will now be what? 0 cancel 0. In our primary school, if you cancel a 0, move. If you cancel a 0, move. So what do you have? V in dm cube is equals what? This is the point. So 0 point, you have 0 here. 0.5 what now? dm cube. If I say 20 liters, what is it equal to? 20 dm cube, because 1 dm cube is equals 1 liter. So 20 dm cube is equals 20 liters. 40 liters is how many? 40 dm cube. It's more or less based on curriculum. The British curriculum, Nigeria, they use British curriculum, so they use dm cube. Then US curriculum, now liter. You get what I talk. So let's continue. Now, I think this should be done. So let's move ahead. You can actually help yourself out and then find meter cube and the rest of them, but these are the popular ones you need to know. Now, the next part of the study, or the next definition under volume, which you must take note of, is molar volume, right? Molar volume, right? Molar volume. Just in case you see a question and you hear the term molar volume, what does it mean? Molar volume is the volume. 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 Molar volume is the volume of 1 mole Molar volume is the volume of 1 mole of a gas. Molar volume is the volume of 1 mole of a gas at STP. We'll still talk about STP, so don't worry now. Molar volume is the volume of a gas at STP. So what do I mean? I talked about it earlier on and said that 1 mole is not the same thing as 1 molecule. A molecule is a particle. A mole is a quantity of measurement. So have this in mind. When you're looking for the volume of 1 mole at SCP of a gas, it is referred to as what? Molar volume. The name, molar. So 1 mole volume. Now, with that said, you're right. It has a value of 22.4 dm3. It has a value of 22.4 dm. So whenever you see molar volume, the value for molar volume is how many? 22.4 dm3. Whenever you see molar volume, the value for molar volume is what? 22.4 dm3. Whenever you are dealing with molar volume, the value for molar volume is what? 22.4 dm3. Whenever you are dealing with molar volume, the value for molar volume is what? 22.4 dm3. Now, with that said, moving ahead, you have that. If you have a question, okay, can we convert the molar volume to cm cube? That's 22.4 dm cube. What is the value in cm cube? How did you get it? V in cm cube is equals V in what? Dm cube times 1000. So what do you have as a value in cm cube? 22.4 times 1000. What do you want to give you? 22,400. 400 watts now? Cm cube. I hope I'm communicating. Good. So just have that in mind. Now, with that said, we move into the next quantity of measurement or quantity that quantifies gas laws and gases. I meant to say pressure. Pressure, right? Pressure. Pressure. Anyone? Pressure or whatever. Mona, go find the actual pronunciation, though, because most of you will have this thing ringing in your head as you enter. Pressure. Okay, let's continue. Now, are we all done? Are we all done? So with that said, we can move ahead. Now listen. Whenever you are dealing with a particular gas, or you are dealing with gases, first of all, it is quantified by the unit or the quantity pressure. So what is pressure? Pressure is simply defined, in generally speaking, as force per unit area. What is pressure defined as? Force per unit area. So whenever you're looking at the force applied to a given area, pressure is equals force per unit area. You are talking about pressure, force per unit area. Now, if you are a maths or physics student, a proper maths or physics student, pressure is directly proportional to force, and pressure is inverse proportional to what? Area. With this said, if you want to have a high pressure for a given amount of force, the area has to be what? Less. If you want to have a high pressure area, you know, if I said this, I'll keep saying this. If you are dealing with inverse proportionality, if one of the quantity now bago, the other quantity will be bothering. It will be doing what? If the first one is bagoring, the other one is doing what? That is what inverse proportionality implies. As this one they go up now, the other one go to do a thing, they go down. That is inverse. In the case of direct, as this one they go up, this one they also go up. Now imagine you are asked out and your boo said that you are going to the beach. Amongst these two shoes I will draw, pick the one you wear. I don't know what I'm doing. Woo! God. We'll see. So which one are you wearing to the beach? A or B? Those online, which one will you wear to the beach? Some people going to ask whether this thing should have been an animal. But now shoe. So which one you go wear? B. Now, the reason you are going to wear B to the beach is simply because of this guy. Pressure and no. Online, they just say they not go wear anyone. Wow. Don't worry. I'm an artist in the mind, I think. Have you seen costly artworks? Rubbish. You see something like this. And there was only for $4 million, not naira. Yes, behind this shoe now, there's a meaning. You understand? They will draw Mao and tell you guys. Now, let's continue. Now, the reason for choosing this flat shoe is because when you go to the beach and you are walking with the flat shoe, you will not sink. But when you are walking with the koi, what will happen? You will continually be sinking. Now, listen. The simple reason is this: smaller area, higher pressure. That's why. That is mathematics. That is physics. The koi has smaller area. Because it has smaller area, it will have higher pressure. If pressure high, you're going to sink inside ground. But when you come to the sneakers, it has larger area, so lower pressure. Am I communicating? Okay, so that's that. But this is not the part. Chemistry questions will concentrate on. This is for your physics. One of the major parts they will concentrate on is this. Right. Pressure of gases. Pressure of gases. Pressure of gases in a container. Pressure of gases in a container. Take note of this. Pressure of gases in a container is exerted as a result of collision. Pressure of gases in a container is exerted as a result of collision between the gaseous molecules, and the walls of the container. It is not just between the gaseous molecules, but when the gaseous molecules hit the wall, pressure is exerted. You talk about collision between molecules when you talk about Arrhenius theory. Arrhenius collision theory states that for a reaction to occur, particles or reactants must collide. That one they different. Now collision theory. If the molecules are colliding with each other, you are dealing with collision theory. But when you're talking about pressure of gases, the molecules or particles must collide with the walls of the container. Oh yeah, let's continue. With that said, pressure is measured by the following units. Pressure is measured by the following units. These are the popular ones in chemistry, so write all of them. You have ATA. You have what? ATA. That's atmosphere. That's what? Atmosphere. It is not automated teller machine. Millimeter mercury, mmHg. Now, if you have a question, they don't need to say the pressure is this. Once you see 1 atm signifies pressure. Millimeter mercury. You have centimeter mercury. You have torr. You have bar. You have Pascal. You have Newton per meter squared. Okay, now please put this down. Put this down. Wait the other one. Okay, so we have these guys, the four of them. Pascal, blah, 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 blah. Put them down. Now, please listen. Whenever you are dealing with pressure, the pressure of gases in Nigeria is not the same thing as the pressure of gases in the United States. Normal now. Our weather for here and weather for US, are they the same thing? No. So that same way, our pressure for here and our pressure for US is not the same thing. It's more or less dependent on so many reasons, but then majorly has to do with the regions located at the equator, regions located at the polar regions and stuff like that. Now you do that in your physics, but listen, have this in mind, that they are not the same. And because gases depend on pressure, if you do a reaction in Nigeria, a gaseous reaction in Nigeria, it is not going to give you the same result as if you perform the gaseous reaction in the United States. Because of that, scientists were able to come together and agreed for a reaction to be accepted anywhere in the world, that reaction must be performed under what we call standard pressure. Under what we call what? Standard pressure. Now listen, that standard pressure, whenever you hear the term standard pressure, standard pressure has specific values. Look at the values of standard pressure. 1 atm. What did I say? Which is equal to 760 millimeter mercury. Which is equal to what? And that 760 millimeter mercury, which is equal to 1 atm, is equals 760 torr. Equals what? 760 torr. Which is equals 76 millimeter, centimeter mercury. And this is equals 10 raised to power 5 bar, which is still equals 1.01325 times 10 raised to power 5 Newton per meter squared, which is still equals 1.01325 times 10 raised to power 5 pascals. Among the units I gave you, is there anyone missing? So put this down. All of them are equal. And this is basically what you use to relate them. If you want to change the units, you are relating it on the basis of this. 1 atm equals 760 millimeter mercury. Or you're relating torr and Newton per meter. So you're relating the two of them. Okay, just put this down quickly. Now, that is pressure. So let's move ahead. Okay, temperature, quickly. Temperature. Temperature is basically the degree of hotness or coldness of a body. And with that said, okay, sorry, put this down quickly if you need to. Put this down quickly if you need to. Those online. Okay. So I guess we are done now. Let's move ahead. Listen. Oh yeah. Temperature, right. Listen. Temperature, right, quickly. Temperature, right. Now, temperature is the degree of hotness or coldness of a body. It can also be defined as the measure of thermal energy. Anything, but that's not my major emphasis. Listen, when you talk about temperature, temperature in chemistry is usually measured in degrees Celsius or Kelvin. What are the major units for measuring temperature in chemistry? Degrees Celsius or Kelvin. Degrees Celsius or what? Or Kelvin. Degrees Celsius or what? Kelvin. When you are measuring in Kelvin, it is referred to as the absolute temperature. It's referred to as what? Absolute temperature. So have that in mind. Temperature in Kelvin is the same thing as absolute temperature. Now note this. Whenever you are dealing with a gas, whenever you are calculating anything with respect to a gas, the temperature involved is the absolute temperature, which is temperature in Kelvin. What do I mean? If you are given a value in degrees Celsius, you must convert it to Kelvin before you start solving. And how do you convert a degree Celsius value to Kelvin? Very simple. Degree Celsius, Kelvin is equals degree Celsius plus 273. Kelvin is equals what? Degree Celsius plus 273. Meaning that if you want to convert to degree Celsius, it will be degree Celsius equals Kelvin minus 273. But the important one is this first one. Kelvin equals degree Celsius plus 273. So class, convert the following values to Kelvin. Convert the following values to Kelvin. Number 1, 33 degrees Celsius. Number 2, 27 degrees Celsius. Number 3, 0 degrees Celsius. Number 4, minus 273 degrees Celsius. Number 5, 19 degrees Celsius. I put this down, everybody. So convert all these values to Kelvin. These are basic, simple things, but these things can make you fail. I said that whenever you're given a question in chemistry that has to do with gas laws, your temperature must be converted to Kelvin values. If you are given in degrees Celsius, convert it to Kelvin. If it's in Kelvin, you are permitted to solve. So convert those values. Convert those values. Yes, yes, yes. So we have number 1. How did we get number 1? Number 1 is Kelvin is degree Celsius plus 273, which is what? What is degree Celsius value? 33 plus 273. What do you have? 306. Number 2, what do you have? 27 plus 273. What do you have? 300. Number 3, what do you have? 27. Okay, what is the degree Celsius value, please? No, what is the degree Celsius value? 0, right? So we have 0 degrees Celsius plus what? 273. So what do you have? 273 what? Kelvin. Please indicate the units. Kelvin. Kelvin. Okay, what is number 4? Y. Minus 273 plus 273, which is going to give us 0 Kelvin. Then finally, number 5. Minus 19 plus 273. What's our answer? 254 Kelvin. Those online, I hope our answers are corresponding. Those online, I hope our answers are corresponding. 273. Guys, they should write it orderly now. 303 or 306. Okay, so the answer should be orderly. Here is 306. It's 33, not 30. Now, with that said, we are going to continue. Listen, but before I leave temperature, listen. I'm just stating this thing. The gas laws, we're going to run them down at once. But listen, before I continue, I just want to mention this, that some absolute temperature has a particular value called the absolute zero. So when you're measuring temperature, what is the absolute zero? Absolute zero is that temperature at which all gases cease to exist. So the temperature of a gas where any gas at all will stop existing is referred to as what? Absolute temperature. So put that down. Sorry, not absolute temperature, absolute zero. Sorry, I take it again. Absolute zero, right? Absolute zero. Absolute zero is the temperature at which gases cease to exist. Absolute zero is the temperature at which gases cease to exist. So when gases stop existing is when the temperature is at absolute zero. Full stop. Now you write the value of absolute zero is how many Kelvin? 0 Kelvin. Absolute zero is equals how many Kelvin? 0 Kelvin. That is the lowest possible temperature. At that temperature, everything that is gaseous stops existing. I know that in very cold regions like Russia, a particular part of Russia, there are some parts of Russia where you literally eat your food on the stove Because if you bring it down and you go to bring spoon, by the time you're coming back, your food must have frozen. Am I communicating? So you eat it where? On the stove. I wonder how they used to beat. My mind imagines wild things. I'm like, maybe they scoop water and throw it. By the time it's falling, his eyes look. But that's my mind. Anyway, so just have this in mind that absolute zero is the temperature at which waiting happens. Gases cease to do what? Exist. Okay, so that's that. And it has a value of 0 Kelvin. What is the value in degrees Celsius? What is the value in degrees Celsius? Can we check it? In degrees Celsius, if absolute zero is 0 Kelvin, 0 Kelvin, but degree Celsius value will be Kelvin minus 273. So degree Celsius value, what is the Kelvin value? 0 Kelvin minus 273. So degree Celsius value will become minus 273 degrees Celsius. So if you are given a question and they say, what is absolute zero? And you don't see 0 Kelvin, what else can you see there? Minus 273. Okay, so that's that. I mentioned volume, I've mentioned pressure, I mentioned temperature, and then finally number of moles. Number of moles, let's just forget about writing that and then get back. I'll talk about that when I'm discussing stoichiometry. Now, gas laws, I will list them, their formulas when they are used. I will list them, their formulas when they are used, and then we'll solve questions. We'll solve questions, at least 5 to 6 questions. You must see a gas law question every year. There's no two ways about it. Every year in JAM, you must, what did I say? Must see a gas law question. So let's start with the first one. The first law is Boyle's law. It's Boyle's law. Now, Boyle's law is the relationship between pressure and volume at constant temperature. So please listen. Whenever you see a question that relates pressure and volume at constant temperature, pressure and volume at constant temperature, what do you have? Boyle's law. Straightforward. The formula is this. V1, P1 is equals V2, P2. Please, what is the condition for using Boyle's law? Volume and pressure related, constant temperature. So if you are given a question and you are told the volume of a given mass of gas is 10, given that its pressure at 10 cm cube is 25, what will be the volume when the pressure is raised to 30? If you notice, we are relating volume and pressure. Once you hear the term at constant temperature, please, who are we going to be talking about? Boyle's law. Okay, we go to the next one. Number 2, Charles' law. Charles' law is V1 over T1 equals V2 over T2. Charles' law states that the volume of a given mass of gas is directly proportional. Volume of a given mass of gas is directly proportional to absolute temperature. If you are given a temperature in degrees Celsius and you apply it to Charles' law, it is wrong. If your temperature is in degrees Celsius, the first thing you need to do before solving is convert it to what? Kelvin. I don't show now how they take converter. May nobody village will carry people to solve rubbish. So if you are given a question and it has degrees Celsius, you should convert it to what? Kelvin. Now, how do you get it? V1 over T1 is equals V2 over T2. Please, what must be constant? Constant pressure. Please, if you see a question and they end it or start it with at constant pressure, they are relating volume and temperature, and you hear at constant pressure. Please, who are you talking about? Charles' law. Now, about Boyle's law, one question that could come out for Boyle's law is this. Listen. Which of the gas law constants is equivalent to? Which of the gas law constants is equivalent to work done? Boyle's law. How did we get it? Boyle's law is V inversely proportional to P. And if V is inversely proportional to P, V will be equals K over what? P. If you have V equals K over P, we know what this implies now. K is constant. So K is equals what now? VP. Now let's look at VP. What is volume? Volume is length times length times length. That's volume. What is pressure? Force over area. Area is length times length. What do you notice here? Length cancels length. Length cancels length. So what is remaining? length times force. Work done is force times distance. Boyle's law constant is force times length, which is a distance. So you have that work done equals force times distance. Boyle's law constant. Boyle's law constant equals force times L, which is a distance. So which one of them? You have that Boyle's law is equivalent to what? Work done. Am I communicating? This is your dimension in physics, but these questions could come out in JAM, chemistry, I meant to say. So put that down, that the gas law equivalent, the gas law constant equivalent to work done is Boyle's law constant. The gas law constant equivalent to work done is Boyle's law constant. The proof is on this side. The gas law constant equivalent to Boyle's law constant. The gas law constant equivalent to work done is Boyle's law constant. Oh yeah, let's go to the next one. Number 3, quickly. Amonton's law. Amonton's what? Law. What is Amonton's law? Listen. It is the relationship between pressure and absolute temperature. So you have P1 over T1 is equals P2 over T2. Where do you use this? When you have constant volume. So if you are reading your question and they tell you that volume is constant, they tell you that volume is what? Constant. They tell you that volume is constant and you are relating pressure and absolute temperature. Whose law are you dealing with? Amonton's law. Yes, some people will call it pressure law. What is the other name? Pressure law. That's what most textbooks will call it. So it's the same thing. If you see Amonton's law or pressure law, you are relating pressure and temperature at constant volume. You are relating what? Pressure and temperature at constant volume. Okay. I would like to clean this so that we'll move ahead. Now, what if you have a scenario where nobody is constant? Everybody's value changed. The volume changed, the pressure changed, and the temperature changed. You will now use what we call general gas equation. So number 4, general gas equation. What is general gas equation? Equals V1 P1 all over T1 is equals V2 P2 all over T2. Please remember, if you are dealing with temperature, what did I say must be constant? I'm sorry, what type of temperature? What temperature do we use? Absolute temperature. If you are given temperature in degrees Celsius, you are supposed to convert it to what? Kelvin. Before you start solving. I take it again. If you are given what? Temperature in degrees Celsius, you are supposed to convert it to Kelvin before you start solving. With that said, what do we have? You have that where we use equation, general gas equation, is when what happens? When you have no constants. No constants. When you have no constants, everybody changes, volume changes, pressure changes, temperature changes, no constants, you use general gas equation. Okay, we go to the next one, which is number 5. And number 5 is Avogadro's law. Avogadro's law. Now listen, Avogadro's law states that equal volume of gases contains the same number of moles. Avogadro's law states that equal volume of gases contain the same number of moles. Avogadro's law, equal volume of gases contain the same number of moles. What it implies is that the number of moles are directly proportional to the volume. Number of moles are directly proportional to the volume. So if you have a question that relates number of moles to volume at constant pressure and temperature, N1 over V1 is equals N2 over V2. So put that down. Put that down. That is Avogadro's law. That is Avogadro's law. Then number 6, ideal gas equation. Ideal gas equation. Now, ideal gas equation is given as PV equals nRT. So I'm listing on the formulas so that when we start solving questions, we'll just look at formulas, solve questions, and that'll be that. Ideal gas equation is equals PV equals what? nRT. P is pressure. V is volume. N is number of moles. R is what we call gas constant. R is what we call what? Gas constant. And T is absolute temperature. T is absolute temperature. Put that down. Quickly, quickly. We don't have all the time in the world. We want to see if we'll answer questions before we go on a short break. Okay. So we are done with that. We're going to move into the next one. Now, after ideal gas equation, the major gas laws I feel most students have issue with is Gay-Lussac's, Dalton's, and Graham's. So we're not going to concentrate on these first 6. We're going to concentrate on these ones we're about to write. So I will write down some things, mention something. As I'm discussing these ones now, I'll be laying emphasis on some things. A major gas laws that students usually have issue with is, let's start with Dalton's law of partial pressure. Number 7, Dalton's law of partial pressure. Now, please write. You will state this law because I want to explain this. Dalton's law of partial pressure. Now, Dalton's law of partial pressure is one of the easiest laws. All it is trying to say is that if you have a mixture of the total pressure, just check for the pressure of the individual ones and add everybody together. If you have 2 gases, hydrogen and nitrogen, hydrogen has a pressure of 2 atm, nitrogen has 4. Please, what is the total pressure? 2 plus 4. What is the answer? 6. 2 plus 4. What is the answer? 6. So write it down. Dalton's law of partial pressure states that in a mixture of gases, Dalton's law of partial pressure states that in a mixture of gases, Dalton's law of partial pressure states that in a mixture of gases, Dalton's law of partial pressure states that in a mixture of gases, Dalton's law of partial pressure states that in a mixture of gases, in a mixture of gases that are not chemically combined together, in a mixture of gases that are not chemically combined together, in a mixture of gases, in a mixture of gases that are not chemically combined together, Dalton's law of partial pressure states that in a mixture of gases that are not chemically combined together, the total pressure is equals the sum of individual partial pressures of the constituent gases. The total pressure is equals the sum of individual partial pressures of the constituent gases. The total pressure is equals the sum of individual partial pressures of the constituent gases. The total pressure is equals the sum of the individual partial pressures of the constituent gases. You see all this English where we talk now? See what it means. If you are looking for total pressure, it is equals P1 plus P2 plus P3 and so on and so forth. So if you have a mixture of gases, please listen. If you have a mixture of gases, and let's say you have argon. Is argon a gas? Yes. And the pressure of argon is 4 atm. You have helium, and the pressure is what? 3 atm. You have nitrogen. The pressure is 5 atm. And you are asked, what is the total pressure? What is what? Please, this is simple mathematics. P total is equals what? What is P1? 4 atm. What is P2? What is P2? 3 atm. What is P3? 5 atm. If you add everybody together, what is it going to be? 4 plus 3, 7, 7 plus 5, 12 waiting atm. This is the first part of Dalton's law. This is the first part of Dalton's law. So note that once you are given individual partial pressures, how do you find the total pressure? Add everybody. But what if you are expected to find a particular partial pressure? Let's look into it. Let's look into it. I'm cleaning this. You have that I'm looking for P1. If I'm looking for P1, sure, everybody will cross over. It will be P total minus P2 minus what? P3. It will be what? P total minus P2 minus P3. It will become what? P total minus P2 minus P3. What will it become? P total minus P2 minus P3. So if, for instance, I told you that the total pressure is 17 atm, the total pressure is 17 atm. The total pressure is 17 atm. What is the pressure of nitrogen in this mixture? Yes, what do we have? How did you get 10? You are looking for the pressure of nitrogen. It is going to be 17 minus what? 4 minus 3. If that happens, what is this going to be? 10 atm. So have that in mind, that whenever you are dealing with partial pressure, the individual pressures added together will give you the total. If you are looking for one of them, total minus the individual. Please, is there any confusion at this point? Those in the live class, is there any confusion? Those online, respond if you please. Respond if you please. If there is any confusion, respond. Okay. If there is any confusion, please respond. If there is any confusion, please respond. Now, if you are responding, you are telling us where your confusion is coming from. Don't just say yes. They are not seeing the board. It's too dark. It's not clear. Eh? Like cleaning a big video. Okay, so for those that are not seeing it clearly, please bear with us. We are working on it so that it will be streamed better. But for now, please bear with us. So, okay. Now, some of the reasons why you might not be seeing this clearly is from our own end. However, you can try increasing the resolution. Don't be too stingy with your data. Don't be too stingy with your data. So please give it small like 360 or 420. Maybe at least the seaboard is I don't think it's from our transmission, but just help yourself out by increasing the. Now listen, let's continue. Now, this is the simple part of this law. Try to stay awake. Try to stay awake as much as possible. Yes, we have stretched beyond our expected or proposed time, but let's just try to stay awake. Now listen. By the time we are done with this, I said the team for this particular exam preparation is 90 or what? Or nothing in chemistry. So listen. There are certain questions you will see where you are expected to find the partial pressure of one gas, but they will not give you the partial pressure of the other ones. You are expected to find the pressure of one gas, but they will not give you the partial pressure of the other ones. For instance, try this question. Right, everybody. What is the partial pressure of nitrogen? Those online, please try to join us. What is the partial pressure of nitrogen? Given that the total pressure of a mixture of, given that the total pressure of a mixture of 2 moles of nitrogen, 2 moles of nitrogen, 3 moles of argon, 3 moles of argon, 2 moles of nitrogen, a mixture of 3 moles of nitrogen, 2 moles of nitrogen, 3 moles of argon, and 4 moles of helium. Given that the total pressure of a mixture of 2 moles of nitrogen, 3 moles of argon, and 4 moles of what? Of helium is 2.7 atm. Is 2.7 atm. So in this particular question, please get on to listen. Everybody listen. It's past time. In the next 15 to 20 minutes. What time is it? 11:56. In the next 10 minutes. Yes, in the next 6 minutes, we'll go on a break. But let's finish Dalton's law. So listen. This part is very important. You will not see those simple ones we talked about. So please, if you are sleeping, wake up. I speak my voice into your earpiece, your speakerphone, whatever you are using. Wake up. This is time to shine your eyes. The other parts we have been doing, you can walk over it. But this one now, you will not see some of these things I'm about to say in your textbook. So listen. Whenever you are given a question that has to do with pressure, and you notice that they gave you total pressure and said find partial pressure. Normally, now minus you're supposed to. But that is if you are given the partial pressure of the other gases. How do you know that you are giving partial pressure? ATM, bar, what else? Millimeter mercury, centimeter mercury, and so on and so forth. That is that for pressure. But then, in this question, did you notice that you were not giving partial pressure of other gases? Instead, you are giving what we call number of moles. So in this case now, to find the partial pressure of a gas, use this formula. Please listen. Whenever you are looking for the partial pressure of a gas and you are not giving the other partial pressures. You can't solve it with that one we gave. You use this thing. Partial pressure of gas is equals mole fraction. Is equals what? Mole fraction of gas multiplied by total pressure. Please put this down. Partial pressure of a gas is gotten by mole fraction of the gas multiplied by total pressure. Partial pressure of a gas is equals mole fraction of the gas multiplied by what? Total pressure. Partial pressure of a gas is equals mole fraction of the gas multiplied by what? Total pressure. Partial pressure is equals mole fraction of the gas multiplied by total pressure. Now listen. With this said, what is mole fraction? Mole fraction is simple. Mole fraction is gotten by number of moles of the gas you are dealing with all over the total number of moles of gases. That is N1 plus N2 plus N gas. If you are looking for mole fraction, how do you get it? The number of moles of gas you are dealing with divided by the total number of moles of gases inside that particular container. That is how we are going to get what we call mole fraction. So I take it again. If you are looking for partial pressure of gas, what do? Mole fraction of the gas multiplied by total pressure. I take it again. How do you get it? Partial pressure of gas equals what? Mole fraction of gas multiplied by total pressure. Let's get to work and solve this question. So listen. The new formula we are going to be using is pressure of gas will now be equals N1, that is N of gas bar, all over N1 plus N2 plus N3 multiplied by P total. Multiplied by what? P of gas is equals number of moles of gas all over N1 plus N2 plus N3, all multiplied by P total. All multiplied by P total. So let's look at our question. Those online and those here, can you try solving this question with this formula? Try it before I try it. Be fast. Okay, I'm seeing answers already online. 0.5, 0.6. What are you getting there on live? Your brain is shutting down. I pray for you. May it not be jam score that will wake your brain up. In Jesus' name. Amen. For the fear of 120 in jam, please wake up. I know you are supposed to be sleeping, but please wake up. For the fear of what? 100 and what? 20. What did I say you should do? Wake up. I'm going to get to that. All right, now let's solve it together. Watch this. Watch this. I want to clean this board. I want to listen. When you are looking for the partial pressure of a gas, it is equals number of moles of the gas you are looking for. Number of moles of the gas you are looking for divided by N1 plus N2 plus N of the gas multiplied by the total pressure. So please, class, listen. Let's read the question together. Can we all read that question? Want to ready go? What is the partial pressure of what? We are looking for nitrogen. So we have the partial pressure of nitrogen is what we're looking for. What are we given? Number of moles of nitrogen is how many? 2 moles. Okay. Number of moles of argon is how many? 3 moles, right? Number of moles of helium is what? 4 moles. What else did they give us? The total pressure is 2 point what? 7. 2 point what? 7 atm. So P total is equals 2.7 atm. 2.7 atm. Now, let's apply all these values here and see what we are going to get. Please listen. Please listen. What do we have now? You have that the pressure of the gas is equals. What is the number of moles of the gas? Okay, we are looking for nitrogen. So pressure of nitrogen, what will it be equals? What's the number of moles of nitrogen? 2. All over 2 plus 3 plus 4. Add everything that is number of moles multiplied by what is the total pressure there? Can we look at it? What is the total pressure? 2.7. So if that is the case, our P of N2 will now be equals 2 over 9 multiplied by 2.7. Now let's do a little division here. 9 here, 1. 9 here, 0.3. So our pressure of nitrogen is going to be equals 0.6 what? atm. Sorry, is it clear? Not clear. Not clear. Okay. Those online, clear or not clear? Yet to be clear, please confirm. Clear, not clear. Understood, don't understand. So that I'll know if yes. Okay, so I will try to listen. Now, what I will try to explain this again. Please listen. For those that have not gotten it clearly, with the second gas, if you are asked what is the partial pressure of argon, what is what? The partial pressure of argon. Do we have the number of moles of argon here? What is it? 3 moles. Okay, so let's solve that one together. If you are asked to find the partial pressure of argon, this is going to be very simple. Partial pressure of argon is equals number of moles of what? Argon divided by N of argon plus N of nitrogen plus N of helium multiplied by how many? P total. Oh yeah, let's do this together. P of argon is equals, what is the number of moles of argon? Look at the board. How many there? 3. Divided by, add everybody together, it is going to be 3 plus 2 plus 4 by 3 plus 2 plus 4 multiply. What is the total pressure in the question? 2.7 atm. Therefore, what do you have? P of argon will be equals 3 divided by 9 times 2.7. Class, what do you have? 301, 303, 301. So what do you have? So pressure of argon is equals 0.9 atm. At this point, let's confirm. Is it clear? Okay. So please try it. Remember the formula. Partial pressure of gas equals partial pressure of gas equals number of moles of gases all over total number of moles of gases times the total pressure. Okay, let's move ahead for want of time. I will now talk about one last thing in Dalton's law. When we come back after our break, we would finish the remaining two and get into hotter parts. Huh? Question. Okay, I have a question here. The question says, oh yeah, everybody. What we just solve? Yes, now we just solved it. What is the partial pressure of nitrogen, given that the total pressure of a mixture of two moles? That's what we solved now. That's what we solved. Oh yeah, let's go ahead. What if I had said find the partial pressure of helium? Oh yeah, solve. Partial pressure of helium. At this point, do you need to use this formula, Steph? You already have P total is equals what? P of argon plus P of nitrogen plus P of helium. Is it not? 2.7. We have argon as what? 0.9. We have nitrogen as 0.6. What is helium going to be? P of helium. Yes. What is it going to be? 2.7 is equals, add these two guys. What do you have? 1.5 plus P of helium. Therefore, P of helium. Therefore, P of helium. The partial pressure of helium is going to be equals 2.7 minus 1.5. So what is your answer? 1.2 ATM. Easy. Very. You know, so if you solve with the other formula still, but not the same thing. Oh yeah. With that said, I will talk about one final part so that when we come back, Gay-Lussac's Grahams, and then we get into pH and pOH. So please still stay tuned and listen. Now listen. When you talk about a gas, every time a gas is collected over water, it is referred to as a wet gas. Every time a gas is collected over water, what is it referred to as? A wet gas. What makes it wet is water vapor. So anytime you see a question, and that question involves collection of a gas over water, just know that that gas is not alone. The gas also has water in it. Every time a gas is collected over water, that gas is not what? Alone. It has what? Water. So if you see a question and you are told chlorine is collected over water, it means that Cl2 also has H2O. Cl2 also has what? H2O. So if they tell you that you have a total pressure here, this total pressure is Cl2 plus H2O. I take it again. Whenever a gas is collected over water, it is referred to as what? A wet gas. Meaning that the total pressure at that point is not legit. I take it again. The pressure of a gas collected over water is not legit. The pressure of a gas collected over water is not what? Legit. So have this in mind that whenever you see a gas and they say a gas collected, you know they're legit. It's not correct. For you to find the legit one, you need to listen to what I'm saying. So listen. Pressure, total pressure of a gas collected over water is made up of the pressure of the dry gas plus the pressure of water, which is called what? Vapor pressure. So if we are to write this in English, VP is what? Vapor pressure. Anytime you collect a gas, the question says a gas is collected over water. Once you hear the pressure of a gas collected over water, or a gas collected over water at a particular pressure, or anytime you see anything with respect to gas collected over water, any pressure given at that point is not what? Legit. So how do you get the legit one? By removing the pressure of water, and you get the legit one. How do you get the pressure of the dry gas? Remove the pressure of what? Of water. I know why I am saying this. So if we are to get that, pressure of dry gas, put this down, is equals what? total pressure is equals what? Total pressure minus what? Vapor pressure. They will give it to you. The vapor pressure will always be given. So it's quite simple. Yes, if you want to get the legit one, remove vapor pressure. If they give you a pressure and tell you pressure of a gas collected in water is 220, pressure of a gas collected in water is what? 220. Once you hear that collected over water, that 220 is not the correct pressure. You will need to remove the vapor pressure for you to get the actual pressure. Now, this spans into your other gas laws because there are sometimes you will have questions and those pressures will be given. I will solve a question or two. But have this in mind that the pressure of dry gas, the legit pressure, is gotten when you remove the vapor pressure from the total pressure. And now listen, without solving, without writing, answer this question. If you have a gas collected over water at a pressure of 250 millimeter mercury, once you hear collected over water, that 250, is it correct? Is it legit? No. A pressure of a gas collected over water is 250 millimeter mercury. If its vapor pressure is 5, what is the original legit pressure? 250 minus what? 5. Hana, once you hear collected over water implies that there are two things there, water and the gas. How do you get the gas alone? Remove the water. It will be given. Don't worry. What did I say? It will be given. So once you have a question, I say pressure of a gas collected over water. Once you hear pressure collected over water, it is not legit. Pressure of a gas collected over water is 300 millimeter mercury. Given that the vapor pressure is 10 millimeter mercury, what is your pressure of dry gas? 300 minus what? 10. What is it going to be? 290. I hope this is understood. Okay, so at this point, we'll be taking our 10 minutes break and we'll be coming back after 10 minutes. So take this time, go and wash your face. Yes, if you have coffee to drink, go and be drinking coffee. If you have boil of hot water to put your leg in, go and bring the boil of hot water. Please, oh, I beg you. I did not say boiling water. If I don't put your leg for hot water before you cook your leg, please, anything you're going to do to stay awake, please do it because the class is actually getting into the more serious parts. As I said, I apologize for streaming this late, but please, we are trying to make this class as effective. Remember, you are writing an exam by this week, and if nothing else, try to make that sacrifices. Thank you very much, because we'll be back in 10 minutes.
1 year why? It's not hard to know.
Okay, for those that are still live, we are trying to give you guys the best possible transmission, and we have noticed that the YouTube transmission is not the same for everybody. So we are going to be transmitting on Facebook. So if your YouTube is not so clear, right in the chat room, you have a link to a Facebook page, which is clearer. For those that your YouTube streaming is not so clear, you have a link, a Facebook link in the chat room. You can also go to the group, WhatsApp group. The link is also there. So go there, and the streaming is better on Facebook. Click on the link. It takes you to your browsers. If you don't see Facebook, click Chrome. As you click Chrome, it will bring you Facebook. Am I communicating? I take it again. If you are live, you are listening, and you are having issues with the quality of the video, we are requesting and pleading, switch to Facebook. The link has been sent to the chat room. Go to your WhatsApp, check it out, click on the link, and go straight into Facebook. It's going to take you to our class, live class, same thing. So it's just that the video quality on Facebook is better than what we have here now. Thank you. Okay, I take it again. If YouTube is better for you, continue with the YouTube link. If Facebook is better, if YouTube is not okay, click on the Facebook link. Go back to the WhatsApp group, click on the link, and it should take you to our live page where you will see exactly the same video, but I think it has a better quality and better streaming. So look into that. Okay. The class is going to be starting now. So let's all come back. Those online, come back. Those online, come back. Back. Okay, those online, please start coming back. We said 10 minutes. That means you're supposed to be back. We're starting class. Okay, please, if you are in class, settle down. Let's continue. For want of time. For want of time. For want of time. For want of time, please settle. Hello. No. For want of time, let's settle. Where Makawa give you? Now, we had slide break, and we're going to continue. I presume you have drank water, you have poured on your face, you have drank coffee. Anyone to keep you awake? Let's listen. YouTube, Facebook, just say hi if you're there, so that we'll continue. So let's continue. Now, those online, I would just like to throw it out there. You can help us and simply suggest likely time you want this class to end. Those on live, when we go end the class? 4 a.m. 4 a.m. Those online, suggest when you want me this class end. Let's continue. Let's continue. Let's continue. Now, okay, so as we said, if you're just joining us on YouTube and probably you did not hear the announcement, we have created a Facebook page and we think the streaming on Facebook is better. That's what we think. We tried both of them and found out that for some people, especially those that are managing data, your YouTube streaming might not be so clear. But if you go to Facebook, it is better there. Facebook, I think, is better there. The YouTube streaming, depending on what phone you are using, and then the pixel, that's what is going to determine your clarity. From our own end, almost at a very clear and quality video, but then the clarity of the video is dependent on what you are streaming from, and secondly, the pixel. However, if you're on YouTube now, you did not hear the first announcement, we have linked you to Facebook. And how do you get into Facebook? The link is already in the WhatsApp group that you connected to this platform from. So go back to the WhatsApp group, click on Facebook, and you check it. If it is better on Facebook, join Facebook. If it is not better on Facebook, go back and click the YouTube one. And that's that. Okay. Having said that, the last thing we discussed was Dalton's law of partial pressure. And when you talk about Dalton's law of partial pressure, we have summarized it under the formulas. We have the first one, P1 plus P2 plus P3 is equals P total. We have the second formula, P1 or P gas is equals N1 over N1 plus N2 plus N3 multiplied by P total. And then finally, we have P of dry gas, which I called a legit pressure. Which I called what? Legit pressure equals P total. What did I call this to? P total is illegitimate. What did I say? It's not original minus zero pressure. So once you have that, these are the three formulas under vapor pressure. These are the three formulas under what? Vapor pressure. These are the three formulas under what? Vapor pressure. These are the three formulas under vapor pressure. So with that said, we are done with Dalton's law. There is no question you will be asked under Dalton's law that these three guys can't solve. Go ahead and try questions. we might not be able to solve as many as possible, but I just touched one or two. So go ahead, solve questions. If you're having confusion, the group is still open. Just simply send us, the questions on the group. It will be opened after a while. And once it is open, send your questions there. It will be completely answered before Thursday. All your questions will be answered. So just have that in mind. The point is we are trying to learn and then cover as much as possible. So be noting the formulas, be taking the notes, go back, restudy it, and try out questions. Now move ahead. Now, once you are done with Dalton's law, the other confusing person is Gay-Lussac's law. So write Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volume. So Gay-Lussac's law of combining volume. Now, right, it states that when gases react, they do so in a volume. When gases react, they do so in a volume. When gases react, they do so in a volume which is in a simple ratio to one another. When gases react, they do so in a volume which is in a simple ratio to one another. When gases react, they do so in a volume which is in a simple ratio to one another and to the product, if gaseous. Simple ratio to one another and to the product, if gaseous. Now, with that said, you write the ratio is depicted by the number of moles of gases in a balanced equation. The ratio is depicted by the number of moles of gases in a balanced equation. So what is this law trying to say? The most important thing is what it is trying to say. Even if you don't remember or understand the complete law, what it is trying to say is this. Listen. If you have a gas, for instance, H2 reacting with O2 to give H2O. H2 plus O2 reacting to give H2O. Once you have this kind of reaction, the first thing you need to do is to balance the equation. What did I say the first thing? Balance the equation. You have two hydrogen, two oxygen, so balancing 2, which changes 1 to 2. So what do you have? This is a gas, and this is steam. So what is the ratio you are seeing? 2:1:2. The ratio you are seeing is what? 2:1 is to what? Is to 2. What does that mean? Listen, if you have 50 cm3, how many will you have here? We're dealing with 2:1:2. If you have 50 cm3, how many will you have here? 25. How many will you have here? 50. If you have 10, how many will you have here? How many will you have here? Are we saying this? So this is Gay-Lussac's law, that there is a ratio. Whenever volumes of gases are reacting, there is a ratio. And that ratio, how do we see that ratio? From the balanced equation. Number of moles in a balanced equation. Number of moles in what? A balanced equation. That is what is going to give us that ratio. The ratio we have in the balanced equation is 2:1:2. Now, how did we get 25? For some of you that might be wondering, it's very simple. If you have 2:1:2, and here is 50, what you simply do is this. If 2 equals 50, which is 2 and 50 on the same side, 2 equals 50. 1 will be equals what? X. So what do you do at this point? You cross multiply. So you have 2 times x, 2x. 2 times x is what? 2x. And 50 times 1 is equals what? 50. 2x equals 50. 2x equals 50. 2x equals 50. I take it again. If 2 is 50, 1 will be what? 2 equals 50. So 1 is equals x. You cross multiply. So you have 2x is equals what now? 50. How do you find x? Cancel. Cancel. What is it going to give you? 25. I hope I'm communicating. So if here is 12, here should be 6. And here, which is still 2, should be what? 12. Am I communicating? Okay, so with that said, in solving Gay-Lussac's law, there are major things we should be considering whenever we are solving Gay-Lussac's law. First of all is this. You are expected to understand the excess gas and the limited gas. I give an illustration, for instance. Let's say you are asked to cook food in your house and your mother happens to bring 50 cups of rice with 5 cubes of Maggi in a bag and asks you, go and cook rice. Now the question is this: 50 cups, 5 cubes of Maggi is inside the bako bag, and she says, go and cook rice. Are you going to use the rice to determine the number of Maggi you're going to cook, or the Maggi to determine the number of rice you're going to cook? Which one? Share the Maggi rice? You will use 50 cups to check if you're going to. Sorry, I ask it again. I ask it again. Those online, please join me. Your mom comes back from the market. She has 50 cups of rice and 5 cubes of Maggi. And then she says, go and cook rice. Will you use the cubes of Maggi to determine the cups of rice? Or will you use the cups of rice to determine the number of Maggi? What is the answer? The cubes. Why? It is the limited one. It is what? The limited one. So have this in mind. Whenever you are dealing with proportions, whenever you are dealing with proportions of volume, whenever you are dealing with Gay-Lussac's law, you use the limited gas. The excess gas is the one that will remain after the reaction. For instance, if you have to use the 5 cups to determine, you will find out that eventually you have rice remaining, meaning that rice is excess. Maggi is what? Limited. Now look at this. If, for instance, you have a question, whenever you're dealing with Gay-Lussac's law and you hear that 2 gases are combining, the fact that they are combining doesn't mean that they will react. What did I say? The fact that they are combining doesn't mean that they will react. So if they say 10 cm cube is combined with 10 cm cube, 10 cm cube is packed with 10 cm cube, it doesn't mean that that is the actual one that reacted. You will need to check according to the ratio. So imagine you have a question, 10 cm cube of hydrogen gas is packed with 10 cm cube of oxygen gas. That one is called the given volume. What did I call that one? Given what? Volume. Given volume. Now, this given volume now is 10 cm cube here. 10 cm cube what? Here. But you are not going to use the given volume to do anything. The given volume is not what you are going to use to solve this question. What is used to solve this question is what we call the reacted volume. What did I call it? Reacted volume. Now, what is the reacted volume? It is dependent on the ratio. So let's find it out. Now, are we going to use this 10 cm cube to determine this, or this one to determine this? You try each of them. Check for this side. Check if it's limited. If it is not, you try for the other one. Now let's try it together. Watch this. If we are to say that 10 cm cube is completely used up, how many of hydrogen will be used? If 2 is 10, 1 will now be what here? 5. I take it again. Let's listen. When you are given a question, the volumes that you are given that combine does not necessarily represent the ones that will react. So when you are given a question, you're told 10 cm cube is packed with 10 cm cube, it doesn't mean that that is what reacted. For you to find the reacted volume, you need to consider your ratio. The reacted volume is where my concentration is. If you use 10, you check for this, then you use this to check for this. Now let's check it together. If we use 10 cm cube here, how many of hydrogen are you going to use? 5 cm cube. It's common sense because if 2 equals 10, 1 will be equals x. Now notice something. We completely use 10 here and use 5 out of 10. So what is going to be remaining here? 5 cm cube. So you notice something. The gas that remains is called the excess gas. The one that is completely used up is called the limited gas. I take it again. The gas that remains, what do you call it? The excess gas. The one that is completely used up, what do you call it? The limited gas. Now watch, listen. 10 cm cube combined with 10. But which one reacted? 10 would only react with how many? 5. Meaning that there will be remaining how many gas? 5 cm cube. I take it again. Listen. I take it again. You combine 10 and 10. Does it mean that they will react? No. The reaction is based on the ratio. So you use this one to check. You can also use the other one to check. So let's start with this one. 2:1. If we use 10 here, it means that what will be reacting here is 5. Now listen. With this said, what will be the volume of your unreacted gas? 5 cm cube. What is the volume of the unreacted gas? 5 cm cube. With that said, we move ahead. Now, we've discovered one thing, that if here is 10 cm cube and this is 1, here will be what? 5. What will here be? 10. What do you have now? 10:5 is 10. Reduce it to the lowest term, you'll get back this ratio. That's when you know your reaction is correct. If you try to reduce it and you don't get this ratio, then it is not correct. With this said, the other part of Gay-Lussac's law, which is important, is what we call residual gas. What we call what? Residual gas. How do you get the residual gas? I want to clean this, so just have this in mind. The residue gas or the residual gas is gotten by volume of unused gas plus volume of gaseous product. Volume of unused gas plus volume of gaseous product. Volume of unused gas plus volume of gaseous product. Gas plus volume of gaseous product. Volume of unused gas plus volume of gaseous product. Now, in our question, we found out that the unused gas is the one that is remaining. The gaseous product is the volume of the product. So let's look at this question. Everybody, let's write this down. Solve quickly. You write. Oh, sorry. "50 cm cube of hydrogen as packed with 20 cm cube of oxygen. 50 cm cube of hydrogen as packed with 20 cm cube of oxygen. 50 cm cube of hydrogen are packed with 20 cm cube of hydrogen at 100 degrees Celsius and 1 atm. 50 cm cube of hydrogen are packed with 20 cm cube of oxygen at 100 degrees Celsius and 1 atm. 50 cm cube of hydrogen are packed with 20 cm cube of oxygen at 100 degrees Celsius and 1 atm. Full stop. The total volume of the residual gas is dash. Okay, so I'll let you guys try it out based on what we just discussed. Then I'll solve it. So try. You have residual gas, residual gas, same thing. Okay, so I'll be solving it. I would like to take this away. Now, for us to for us to be able to understand this, the first thing you need to do is to write down a balanced equation of the reaction. Write down a balanced equation of the reaction. So what equation are we dealing with? Hydrogen is reacting with oxygen. And what is it going to produce? Water. When you have this reaction now, the next thing you do is to balance it. How do you balance it? 2, you have 2. Put this in order. What are you going to get? 2 moles reacting with 1 mole is to 2 moles. Now, they told us that the given volume is 50 combined with 20. What I told you, don't consider this one. This is not what you're supposed to be using. What you're supposed to be using is the reacted volume, which is determined by the ratio. So let's get the ratio. If we use 50 to check, I hope you know that here you will have 25. But then, do you have up to 25 in this case? No, which means that using 50 is wrong. If you use 50, what you need is what? 25. But in your question, do you have up to 25 oxygen? No, meaning that using 50 to check is what? Is wrong. What do you now do? You use the other person. So let's use the other person. If we are to use oxygen, it will be 20. If 20 is here, what are we going to have as this? We'll have 40. It's common sense. If 1 is equals 20, 2 will be equals x. Cross multiply, x is equals what? 40. So I take it again. Using 50. If you use 50 for reacted volume, you will need 25. You will need how many? 25. But you don't have up to 25. Because you don't have up to 25, you are not supposed to use 50 to take it. What are you going to use to check it? 20. Let's use 20. 20 to check this guy, what will it become? 40. Now, if you notice, we were given 50. What we use is how many? Because this is the reacted volume. So how many is going to remain? 10. So finally, if we are asked to find the residue gas, I told us that the residue gas, what is the residue gas? Residue gas is equals volume that did not react. What is the volume that did not react? 10. 10 cm cube did not react, plus volume of gaseous product. What is the volume of gaseous product? Now, look at this thing. 2:1:2, meaning that we are going to have 40:20 is to what? 40. Because if 2 is 40, 2 here would also be 40. So what do you have? 10 cm cube plus how many? 40 cm cube. Therefore, the residue gas or the residual gas is equals 50 cm cube. We have this. So I take it again. What you use to determine is what we call the limiting gas, not necessarily the smaller gas, but the one that when you check it, it will finish. Try for this one, then you try for the second one. Once you do that, any one of them that is the limiting gas is what you're supposed to use. So put this down. Now, having said this, I will just give you the formula for Graham's law, and then we get into solubility. We get into what? Solubility. Now, the formula for Graham's law, further questions on that should be directed to me later. But the formula for Graham's law is simply this. Please listen. The formula for Graham's law is this. R1 all over R2 is equal square root of RMM2 all over square root of RMM1. R1 over R2 is equals square root of RMM2 all over square root of RMM1. Or R1 over R2 is equals square root of VD2 all over square root of VD1. Now, please notice there's an inverse proportionality. So whenever you are dealing with this, always identify or note the inverse proportionality. Now, there are certain questions where time is involved. If time is involved, have this in mind, that rate is equals volume over time. Rate is equals volume over time. So whenever you are considering the rate of a chemical reaction or the rate of diffusion of gases, rate of diffusion of gases, rate is equals what? Volume over time. That means that time will be equals what? Volume over what? Over rate. If you have a question and it is time related, rate is equals volume over time. Time is equals volume over rate. So have this in mind, that when you're expected to find time, for instance, let's look at this question. Everybody, let's look at this question. Let's look at this question. Yes. Okay, so now, how would you know that you are dealing with Graham's law of diffusion? Whenever you hear the terms rate, whenever you hear the terms what? Rate of diffusion, you hear the term how long. You hear the term what? How long. You hear the term how fast. You hear the term how fast. So when you hear rate, you hear the term time, you hear how long, or you hear how fast. What should come to your head is any of these ones. R1 over R2 is equals square root of RMM2 over square root of RMM1. If you don't have RMM, you might be given vapor density. And I've already established the relationship between vapor density and RMM. VD is equals RMM all over 2, which means that RMM is equals VD times 2. So I take it again. The questions you'll be asked for you to think of any of these formulas. Number 1, how long? What did I say? Number 2, how fast? What did I say? Number 3, rate. What did I say? And then number 4, time. So once you hear any of these 4 things, you are talking about Graham's, especially when it has to do with diffusion of gases, especially when it has to do with what? Diffusion of gases. Okay, so let's try this question. Everybody write. Write 200 cm cube of oxygen. 200 cm cube of oxygen diffuses through a porous plug in 50 seconds. 200 cm cube of oxygen diffuses through a porous plug in 50 seconds. 200 cm cube of oxygen diffuses through a porous plug in 50 seconds. How long will 80 cm cube, 200 cm cube of oxygen diffuses through a porous plug in 50 seconds? How long will 80 cm cube of methane, methane is CH4, how long will 80 cm cube of methane take to diffuse through the same porous plug under the same conditions? 200 cm cube of oxygen diffuses through a porous plug in 50 seconds. 200 cm cube of oxygen diffuses. 200 cm cube of oxygen diffuses through a porous plug. Through a porous plug in 50 seconds. How long will it take? How long, will 80 cm cube of methane? How long will 80 cm cube of methane take to diffuse through the same porous plug under the same conditions? How long will 80 cm cube of methane take to diffuse through the same porous plug under the same conditions? Option A, 20 seconds. Option B, 20, let me confirm. The past question I have here says 20 seconds too. Let me confirm. Okay, option A, 20 seconds. Option B, 24 seconds. Option A, 20 seconds. Option B, 24 seconds. Option C, 14 seconds. Option D, 7 seconds. Now listen. 20 seconds, 24, 14, and 7 seconds. Now let's listen. Once you hear the question, in this question, what do we have here? What question is asked here? How long, how fast, rate, which one? How long, meaning that we are looking at time. Once you hear how long, what are you looking at? Time. If you hear how fast, you are talking about rate. Now, we don't have a time-related formula here, but rate is equals volume over time. So any place I see rate, what can I put there? Volume over time. Now let's watch this. Let's try to be smart in this case. Let's identify them first of all. The first gas that was given was oxygen, right? So let's call R1, R of oxygen. And what is the rate of oxygen? Was it given? No. Volume over time. So what is the volume of oxygen given in this question? 200 cm cube. What is the time it will take oxygen to diffuse? 50 seconds. We go to the next one. R2 is equals R of methane. What is the volume of methane in this question? 80 cm cube, right? What is the time? We are looking for the time because they said, how long, right? Check. What did he say? Will it take methane, 80 cm cube of methane to diffuse on that? So are you seeing that what we are looking for now is time? Good. So with that said, let's apply it. What is the relative molecular mass of oxygen? The relative molecular mass of elements is gotten by atomic mass multiplied by atomicity. How do you find the relative molecular mass? It is equals what? Relative atomic mass times atomicity. When you are looking for the relative molecular mass of oxygen, it is equals relative atomic mass times what? Atomicity. The atomic mass of oxygen is what? 16. What is the atomicity of oxygen? 2. Earlier on in the class, I told you, what did I tell you? That you have 4 pieces of information depicted by a symbol. The one written here, atomic number, atomic mass, charge, and what is here? Atomicity. So the atomicity of oxygen in this case is how many? Is 2. So if you have that, 16 times 2, what do you have? 32. Relative molecular mass of CH4 is going to be what? 16. How did we get that? CH4, C is what? 12, plus hydrogen, which is what? 1, times what? 4. What is that going to give us? 12 plus 4, which is equals what? 16. So, for now, we have gotten all the values that we need to apply to our formula. So, let us start applying. Very simple. What is this going to be? Now, remember we said R okay, so let's continue. Sorry. You have that the rate of oxygen all over the rate of CH4. Please listen. Whenever you are dealing with Graham's law, if rate is on top on this side for a particular element, the square root of the relative molecular mass of that element will be down. Rate up, relative molecular mass down. That means rate of CH4 is down here. Where would the relative molecular mass be? Up. RMM of CH4. Now with this, let's get to work. Were you given the arrow of oxygen in that question? No. But are we able to find it? Yes. What is it? 200 over 50. Please, class, what is 200 over 50? So what are you going to have? 4 cm cube per second. In this case, what is still our answer? 80 cm cube all over T of CH4, because you don't have the time. We're looking for that. So let's put it here. What is the rate of oxygen, class? 4. Abi, what is the rate of CH4? 80 over time, which is equals square root. What is the relative molecular mass of CH4? Check according to what we did, 16. What is the relative molecular mass of oxygen according to what we did? 32. Now you can either decide to square both sides or you find the square root. Anyone you want to do is still the same thing. So for easy understanding, we know the principle of squaring both sides to remove square root. If you square both sides, here, all squared, here, all squared. This square will cancel the square root. This square will make this one. Okay, so what do we have now? 4 squared, what is it? 16 over 80 squared is what? 6,400 all over what? T squared. Equals what now? 16 over 32. Now remember, what do we do at this point? Cross multiply. Now, this guy is together, so 16 will multiply, 32 will multiply this guy. Are we seeing the cross multiplication? I take it again. This guy multiplies this one multiplies everybody under. With that said, what it will lead us to is this. We will now have 32 times 16 is equals what now? 16 times 6,400 divided by T squared. Okay, we have our calculators. What is 32 times 16? Yes, quickly. What do you have? 512 is equals, what do you have for 16 times that our guy? 102,400. Remember, all over T squared. Now with this said, what should we do at this point? Cross multiply. This guy crosses, this guy crosses, this over 1. So what do you have? 512 T squared is equals 102,400. Let's see, we're taking it step by step. Please, what do we do at this point? Yes, mathematics students. What do you do at this point? You divide both sides, right? So we have 512 T squared is equals 102,400. Divide 512. Divide 512. Cancel out. T squared is equals what? 200. Is that what we have? Is that what we have? So what is this going to be? T squared is equal, square root, right? So you square root both sides. This goes, so you have square root. Square root of 200. 196 is the closest. So 14 point what? 1. So what is your answer? T is equals 14.1. Now, the trick there is your ability to understand that rate and time are not the same thing. Rate is equals volume over time. If you follow it step by step, those that have issues with understanding it, you have the opportunity to look at the video again. As I said, the video is being recorded and is going to be sent to the group such that you can review it again. Am I communicating? Good. So for now, put this down. Put this down. If you have any questions as regards specific points here, you are permitted to put it up in the chat room, and then I should be able to talk about it. So remember, it all started here, and then it went to here. From here, we went here. Here to here to there. Yes. Great. Whenever you hear the term how long, how fast, time, rate, in relation to diffusion of gases, you are dealing with Graham's law. And Graham's law, know the formula, is this guy. Am I communicating? In this question we talked about, I'm just trying to tell you specific things. If you hear constant temperature is Boyle's law. B1, P1 equals B2, P2. If you hear constant pressure, it is Charles' law. V1 over T1 equals V2 over T2. If volume is constant, which one? Amonton's law or pressure law, I meant to say. Then what if nobody is now constant? What will it become? General gas equation. Am I communicating? You now come down to partial pressure. I've taught us some things about it. Graham's law, you ask easy question, and that is that. Now, we'll be switching to something new. And between these topics, which one do we think we need most? Those online, pH, POH, volumetric analysis, and solubility. pH, POH, volumetric analysis, solubility, and solubility curve. Those online, respond. I have pH, POH, volumetric analysis, or solubility, solubility curve, and solubility product. Which one should we do now? We are awaiting your response. Those here said, what did you post say?
pH and POH.
pH, let me see. How many of you? 1, 2, 3. Solubility, how many of you? 1, 2, 3. Sorry, I take it again. pH, POH, how many? 1, 2, 3. Are you among? 3. pH, POH, volumetric analysis, we have 3 people. Solubility, solubility curve, solubility product. 1, 2, 3, 4, 5. Okay, so physically, we have more votes for solubility, solubility product, and that solubility curve and the rest of them. Okay, so the votes here, we have solubility winning. Online, we have pH and POH. Now, they are all priorities, but I think pH questions do not come out every year, but solubility questions must come out every year. When you talk about solubility questions, you are looking at solubility curve, you are looking at calculations with respect to solubility, and you are looking at solubility product. So we are going to discuss it. I did for Unao. The only problem is that we started the class late. So as much as we can, we'll still keep doing. So listen. However, please settle. Let's continue. Now, we are switching. Solubility. I'll try to explain 1 or 2 things in the next 30 to 45 minutes so that we'll be able to switch to something else. Listen. Now, come on, help me out with this. Okay. Now, when you think about solubility, the first thing I want you to think of is the amount of solute that is contained in a given amount of solvent. Please, let's concentrate. If you are live and watching, if you are in the class, don't sit down here and be wasting your time. Don't sit down here and be wasting your time. So please, I beg you, if you are live, be here. I said, when you are dealing with solubility, you are looking at the amount of solute that is found in a given amount of solvent. For instance, listen, if I put 2 cubes of sugar inside 1 cup of water, 2 cubes of sugar inside 1 cup of water, 2 cubes of sugar inside how many cups? 1 cup of water. The solubility is 2 cubes of sugar per cup. Am I communicating with you? If I put 5 cubes of sugar inside 1 jug of water, the solubility is 5 cubes of sugar per what? Jug. Now, let's switch it a little bit to chemistry units. If I put 2 moles of sugar, 2 moles of sugar inside 1 dm cube of water, please, what is the solubility? 2 moles per what? Per dm cube. Okay, what if I put 10 moles inside 5 dm cube? What will it become? 10 divided by what? 5. What is it going to give you? 2 moles per dm cube. Sorry, am I communicating with us? Okay, so have this in mind, that when you are dealing with solubility, you are not just considering just anything. It is not so much of a calculation. Basically, what you are doing is the solute divided by the solvent. What did I say? What did I say? Solute. Okay, so for now, just write this down. Write this down. Solubility. So you disturb my class. Solubility. Solubility equals amount of solute all over given amount of solvent. Solubility equals amount of solute all over given amount of solvent. So, not minding the unit, what I want you to concentrate on is that when solving solubility questions, solute on top, solvent where? Below. I take it again, not minding the units. When you are solving solubility questions, what I want you to always find, solute where? On top, the solvent where? Below. So please follow me. Watch this. Now, there are different units of solubility, and all these units of solubility are basically dependent on moles or mass. I'm just going to concentrate on the most important ones. So please listen. Please listen. Before I get into that, let's switch a little bit into some basic things in stoichiometry. Whenever you are measuring a substance, there are 4 units. There are how many units of measurement? 4. Whenever you are measuring a substance, there are 4 quantities of measurement. The first one is amount in moles. Is what? The second one is volume, either in dm cube or in cm cube or liters or any one of them. The third one is mass in gram. And finally, number of particles. Put this down for those that are still awake and still in the class. Those that are still awake, put this down. Those that have left their data on and slept off, see you tomorrow. Because by the time you wake up, data giga will go. And it's not my fault. Okay, I am partly to be blamed, but I have apologized and I hope you understand. I take it again. These are the quantities of measurements in chemistry. Now, all of them are related. You know, say if you go market, one buy food, quantities of measurement in the market: cup, painter, rice, derica, bag. Cup, painter, rice, derica, bag. Trailers too. As many quantities as you have, all of them are referred to as quantities of measurement, and they are related to each other. For instance, listen, 20 cups of rice is equal to 1 painter of rice. This relation is going to be used to determine what if I now have 40 cups, two painters. It's common sense, right? Good. Now, that same way in chemistry, you have that your units are related. Your units are what? Related. And let's see the relation. I will just state them. Number of moles is equals mass in gram all over molar mass. I have basically told us something about molar mass. Molar mass is not necessarily the same thing as relative molecular mass. It is absolutely not the same thing as relative atomic mass or mass number. But listen, molar mass value is equivalent to the value of relative molecular mass. I said equivalent, I did not say equal. The value of molar mass is equivalent to the value of relative molecular mass. So when you see relative molecular mass or you see molar mass, they can be interchanged. For instance, the relative molecular mass of sulfuric acid is 98, no unit. Relative molecular mass of sulfuric acid is what? 98. But when you talk about the molar mass of sulfuric acid, it is 98 gram per mole. I take it again, it is 98 gram per weighting mole. Another illustration, the molar mass of chlorine is 71 gram per mole. Am I communicating? The molar mass of chlorine is what? 71 gram per mole. Relative molecular mass is just what? 71. So you notice the equivalence in value, the difference is the unit. Am I communicating with you? So molar mass, molecular mass, we talked about how to find it. How do you find molar mass? You can put this down if you don't know. It is relative atomic mass multiplied by atomicity. Relative atomic mass multiplied by atomicity. Molar mass equals relative atomic mass multiplied by what? Atomicity. Molar mass equals relative atomic mass multiplied by atomicity. Please, if you are online, you are here, and you feel like sleeping. Yes, sorry. All of you, I guess, feel like sleeping, right? Is there anybody here that is seated here that does not feel like sleeping? Very good. Online, do you all feel like sleeping? If you feel like sleeping, you can help us out by clicking the sleeping emoji so that we'll know if we will shut the class and go and sleep. Should we stop the class? Those online respond. Should we go and sleep? Should we go and sleep? Those here, should we go and sleep? We should not go and sleep. We die here, bah? Okay, we'll not die here. Okay, how did I say you find your molar mass? How do you find your molar mass? Relative atomic mass times what? Atomicity. Now listen, that's the relationship between number of moles and mass. Number of moles and volume is N equals volume in dm cube divided by 22.4. Then number of moles is equals number of particles all over 6.022 times 10 to the power what? 23. Please put this down. Put this down. This is a side note. This thing will help us out in so many ways. Put these three relations down. This is particles. So small n is given as your number of moles. The small n is given as your number of moles. Your small n is given as your number of moles. Mass is there and the rest of them. Okay. So with that said, now let's come back. Let's come back. Now, I had to mention this because when we are dealing with solubility, we are going to be measuring substances. We are not done. Those online, should I rewrite it? You are not online. Okay, let's continue. Sorry. Now, as I was saying, sorry for the break in transmission. Rewrite. N is equals mass in gram all over molar mass. N is equals volume in dm cube all over 22.4. N is equals number of particles all over 6.02 times 10 to the power 23. Put this down, okay? So as I was saying about those that want to sleep, if you are feeling sleepy already, stand up, or you sing nursery rhymes. Go down, go down, go down to Egypt, and to follow the road, let my people go. Okay, in nursery school, what song did you sing? Okay, Kokura for Twinkle, twinkle, little star, how I wonder what you are. Up above the sky so kind, like a diamond in the eye. Which other one? Papa is a kind of fruit, Jesus. What? Okay, so like sugar, yellow like Fanta. Everybody likes Papa. Hooray! What? Okay, finally, HIP for the hippopo. PO. You know, in jam, literally, you sing this song to spell hippopotamus. If you've written jam before and you sing hippopotamus. So let's take it finally. Hippopotamus. HIP for the hippopo. PO for the hippopo. And EAMUS for the hippopotamus. Okay, I think I have gotten awake by that song. And if you know, some people didn't sing a lullaby, they don't sleep now. So please stay awake. Now let's continue. That young boy in there press the phone over there. Oh yeah, Kebia. You are chatting with your girlfriend. Leave your babe. Your babe will pass. You will stay here. Oh. Let's continue. You understand? Your babe will get into school and it will no more be your babe again. Hope you know. So let's continue. Yes, now. Oh. You think a one girl will be dating a jam bite? Somebody say, God forbid. It's downgrading. So, Badokwanya, let's continue. Now, let's come back. I was doing all these things so that those online will copy this thing. Solubility. Let's go back. I said the constant thing is solute on top, solvent where below. So let's continue. Anytime you are dealing with solubility, you are dealing with about 3 popular units. Number 1 is mole per dm cube. Number 1 is what? Number 2 is gram per dm cube. Number 2 is what? And number 3 is gram per 100 gram. Number 3 is what? Put this down quickly. I'll try to compress this study. So please put it down quickly. Now, I'll be giving you 4 different formulas that will be applied whenever you are solving solubility in mole per dm cube. And besides, remember the general theory, solute nano, where will solvents be? Solvents none. So if, for instance, I give you a question and tell you, listen, I give you a question and I tell you that 3 moles of a salt was dissolved in 1 dm cube of water. What is the solubility? The salt is the solute now, divided by the solvent. How many solutes do you have? 3 moles. What's the solvent you have? 1. What is your answer? 3 what? Okay, let's say, for instance, you have 5 moles of a solute and it was dissolved in 2 dm cube of water. 5 moles. Solute is where? Top. 5 moles, right? What is the solvent? 2 dm cube. What do? 5, what do you have? 2.5 moles per what? dm cube. So the major emphasis in solving solubility questions is make sure your solute value is where? On the top, and your solvent value is where? Below. Okay, watch this. 3 grams dissolved in 4 dm cube. What is going to be your solubility? Solute is where? 3 grams dissolved in 4 dm cube. Where is the solute? Is 3 grams. Solvent is what? 4 dm cube. So what is your solubility? 3 over 4 gram per what? dm cube, which is 0.75 gram per dm cube. Okay, but that's not majorly. This is the general scope of study. Now, if you are solving questions and the question, listen, the answer you are expecting is in mole per dm cube, I will give you 4 different formulas and conditions. Solubility in mole per dm cube. Now, watch the conditions. Watch the conditions. If you have solute a number of moles, solvent in dm cube, your solubility in mole per dm cube will be equals, you can't see the board. But listen, solute, number of moles, solvent, dm cube. Listen, your solubility is going to be equals, what do you have? Number of moles divided by volume in dm cube. So please put this down. Put this down. Whenever you're asked to find solubility in mole per dm cube, and solute is moles, solvent is dm cube, this formula has given you your answer. For instance, this question here, okay, everybody solve, write it down, solve, put it down, solve. Sorry, I need to find the question first. A loss, but it shall be found. It shall be found by, okay. Both me and the question we have lost. Yeah. Okay, right, yes. Right, quickly. Right. 0.75 moles, 0.75 moles of a salt X, 0.75 moles of a salt X was dissolved in 0.5 dm cube of water. 0.75 moles of a salt X was dissolved in 0.5 dm cube of water. What is the solubility in mole per dm cube? What is the solubility in mole per dm cube? Now, in this question, solute, number of moles, solvent, dm cube. What is going to be your solubility in mole per dm cube? Number of moles on top, volume in dm cube where? Below. Please, what is your answer? What do we have as our answer? Now, what's the number of moles in the question? 0.75 moles. What is the volume? 0.5. If you do this, what is your final answer? 1.5 mole per dm cube. That is if solute is the number of moles, volume is in dm cube. Second condition. There are scenarios. This is condition 1. Condition 2. If solute equals number of moles and solvent equals volume in cm cube, that is, instead of having dm cube, what do you have? Cm cube. The formula you are going to use is solubility equals number of moles times 1,000, all divided by volume in cm cube. Or I put this down quickly. Number of moles. I'm just giving you straightforward formulas that you're going to apply, and then you'll be able to get solubility questions straight up, straightforward formulas. Number of moles. Remember, it is for solubility in mole per dm cube. The third condition, don't worry, we'll solve it. Let me just give everything once. The third condition is if solute is equals number of moles. Mass. Solute is given as mass in gram, which is most of the questions you're going to be seeing. So listen, and solvent is equals volume in dm cube. It is very easy. How did we get it? Now, there's no need to show you derivations. You can actually understand it if you know that N is equals volume, mass over molar mass. With this understanding, solubility is going to be equals what now? Mass over molar mass times 1 over volume in what? In dm cube. The only difference is that if you now have solute equals what? Mass, and solvent equals what? Volume in cm cube. It don't change. What will it now become? S will be equals mass over molar mass times what? 1,000 all over volume in what? In cm cube. I put this down. Put this down. You are lost. Okay. Just put down the formula. Put down the formula. Whether you are lost or not, online and on live, just put down the formula and write these things down separately. We will explain them with questions. So don't bother. Now, as I said, as I am calling the questions, you are going to be looking at your note for now. By the time you go back to study with your notes and try it over and over and over, it gets to stick, so you wouldn't get confused no more. So listen, let's look at this for instance. Okay. Calculate the solubility. Before that, just write, everybody. 1 cm cube equivalent, not equal. 1 cm cube is equivalent to 1 gram. What did I say? 1 cm cube is equivalent to what? 1 gram. 1 cm cube is equivalent to how many gram? 1 gram. Did I say they are equal? No. I just said that they are equivalent. I can use 1 cm cube where I am supposed to use 1 gram. So if I have 10 grams of water, what is it equal to? 10 cm cube of water. If I have 50 cm cube of water, what is it equal to? 50 grams of water. So you can use them interchangeably. That's just what I'm saying. With respect to solubility, you can use them what? Interchangeably. Now, haven't mentioned this. Listen. What do you have at this point? Now, 1 cm cube equivalent to 1 gram implies that 10 cm cube is equivalent to how many grams? 10 grams. 1,000 cm cube. What is the equivalent to? 1,000 grams. Mind you, I did not say equal. I did not say what? Equal. I said equivalent. You can use them in place, especially when solving solubility questions. So everybody, solve this question. Calculate the solubility in mole per dm cube. Calculate the solubility in mole per dm cube of 40 grams of CuSO4, of 40 grams of CuSO4 dissolved in 100 grams of water. Calculate the solubility in mole per dm cube of 40 grams of CuSO4 dissolved in 100 grams of water at 120 degrees Celsius. Calculate the solubility in mole per dm cube of 40 grams of CuSO4 dissolved in 100 grams of water at 120 degrees Celsius. Calculate the solubility in mole per dm cube of 40 grams of CuSO4 dissolved in 100 grams of water at 120 degrees. Now, please, whenever you see a solubility question and temperature is given, do not necessarily mind the temperature, especially in this case. You are not going to use it in the calculation. You are not going to include it in solving. The temperature is simply there. Majorly, solubility is dependent on temperature. So what it is trying to tell you is that at this temperature, you need to be considering this solubility. However, I would like to say that whenever you talk about a saturated solution, the amount of solute in a solvent, the amount of solute in a saturated solution gives the solubility of that substance. Sorry, I take it again. The amount of solute in a given saturated solution is the same thing as the solubility. So when they tell you that a saturated solution is this, that mass contained in a saturated solution is the mass that is associated with what? Solubility. So that you have that in mind. We don't have to necessarily mention that the mass that was dissolved. Once you hear a saturated solution, for instance, when you hear saturation, it means it is completely failed. When you hear unsaturation, it can accept more. Am I communicating? When you hear supersaturation, it don't pass. For instance, now let's say they are supposed to be 100. For instance, yeah, it happened in our class today for the online students. The point of saturation of the Zoom class was 100 students. Immediately we got to 100. Did any other person enter? No. Why? The class was what? Saturated. But when we were counting 90 students, 90, 85, was it saturated? No. 99, was it saturated? No. Immediately got to 100, the class became what? Saturated. Now, one thing about a saturated solution is that even in the presence of undissolved solutes, it will not collect anymore. We noticed that when we got to 100, there were more people trying to enter, but did the class allow anyone? No. Once it becomes saturated, no other thing dissolves. So have that in mind, that if you have, for instance, something like a solution and the solubility is 2 grams per 100 dm cube. Listen, 2 grams per 100 cm cube. And you added 5 grams. Please, how many will enter? This is 100 cm cube. And I told you that the solubility is 2 grams in 100 cm cube. If you add 5, please, how many will dissolve? How many will dissolve? It's 2 grams that will dissolve. That means that how many will be outside? 3 grams. Not minding water, even if you want, put 20. Oh yeah, what if we added 20 grams? How many will still dissolve? 2. How many will remain outside? 18. So a saturated solution does not accept any other thing. Once it gets to that point, it stops accepting. Am I communicating? And I said something that saturated solutions, the masses of saturated solutions, or the masses of the solute in saturated solutions are the masses involved in finding what? Solubility. Just have that in mind. Now, let's get to work in this question. So, we were asked to find solubility in mole per dm cube. And when you are asked to find solubility in mole per dm cube, listen, you have formula number 1, number of moles over volume in dm cube. Formula number 2, number of moles times 1000 all over volume in cm cube. Formula number 3, you have mass over molar mass times volume in dm cube. And the last one, mass over molar mass times 1000 all over volume in cm cube. So please look at your question. What is the solute in this question? 40 grams of CuSO4, right? What is the solvent? 100 grams of water. But I told you that 100 grams is 100 cm cube of water. Now look at this. We are asked to find solubility in mole per dm cube. Which formula has solute in mass and solvent in cm cube? Formula number 1, formula number 2, 3, or number 4? Which one? Check your notes. Be part of the class. Check your notes. Check your notes. Which one? Number 4. So if we are going to solve this question, which one are we going to use? Number 4. Why? Because according to our question, solute is in mass in gram, solvent is in cm cube. You know they gave it 100 grams in grams, right? But I told you that gram is equivalent to cm cube. So when you have 100 grams, what do you have? 100 cm cube. Now with that said, we are going to have mass over molar mass times 1000 over volume in cm cube. Oh yeah, apply this formula now and give me my answer. The options are, everybody apply it. Online, offline, everybody apply it. The options are CuSO4. Okay, then have this in mind. Copper is 64. Put this down. Copper is 64. Sulfur is 32. Oxygen is 16. Option A. Option A. Similar answers. Oh yeah, so you are using the last formula. You know why now? Mass, volume in cm cube. Oh yeah, oh yeah, oh yeah. The last one you go use. Right time now. See, mass over molar mass times 1,000 volume in cm. Those online, do I have answers? Those online, do I have answers? Vera says 2.5. Isabella says 4. Ihechukukano, your option is not in the option. Your answer is not in the option. Promise Nama now, Father Lord. Let me stop it at that point. 2.5, 0.4. Udeji Emmanuel, 0. Okay, let's solve. I've gotten as many answers as I can carry. Now let's go to the board. Those physically, the live students, what do you guys have? 2.5. What do you have? 2.5. Everybody here has 2.5. The 10 of you have 2.5. How many on a day? I don't know. Okay, 2.5. All right, let's check. I'm going to clean the board and then try to solve. Please. And let's look at it. Now, remember the condition for picking this last formula. If solute is in mass, solvent is in what? cm cube. You use that guy. So please, let's go back and put these formulas to our head. We've written them, cram them. Now listen, you are sharing granite. You are hungry. Shawarma. Pizza. Have you eaten pizza before? You are saying pizza. You have eaten pepperoni pizza. Some of you here, you have not eaten pizza and you're asking me to buy it for you. Let's continue. Or your solubility in mole per dm cube. Please, those online, you people are better than us. You can enter the kitchen and carry Gary and come and sit down and come and be chewing. All we have here is board and fan and books and laptops and video cameras and knowledge. So please be chewing this one. Now, it is mass over molar mass multiplied by 1,000 over volume in cm cube. Please listen. This is not hard. And I wonder how you people failed it. I think most of you got it wrong here. That's my highest suspense. Molar mass. I think that's where you guys got it wrong. But then I will show you how to solve it. First of all, the mass given us of the solute is how many? 40 grams. Please, this mass here is the mass of the solute. The molar mass of CuSO4 is gotten by adding everything. What is Cu? 64 plus 32 plus 16 times 4. Oxygen is times 4. That's why we have 16 times 4. What is this going to give us? 64 plus 32 plus 64. Please, what is that going to give us? 100 and what? 60. So please, if you don't have the molar mass, your molar mass, if it is not 160, you have started failing it. Now, What is the volume of water? 100 gram, right? But 100 gram is the same thing or equivalent to 100 cm cube. Now, with that said, let's solve this question. Very simple. Very what? Simple. Now, what is the mass according to the question? 40 gram. What is the molar mass? 160 times 1,000 all over what? 100. 0 cancel 0, 0 cancel 0. Use your calculator, same thing. 0 cancel 0. What do you have? 40 over 16. 4 here is 4. 4 here is 10. 10 over 4. So solubility in mole per dm cube is equals 2.5 mole per dm cube. That's the answer. Okay, put that down. 2.5, you are correct. Any other answer, you are wrong. Please, I hope you noted. I hope you noted where your error came from. Okay, with that said, those still awake, please just be joining us small. Those that have slept, we are recording the video. You are likely to get it. We are recording it such that even if you slept off, you will still be part of the class. Now, as I was saying, some of us here have slept off, even though your eyes are still open. Yes, I can see some of them. Quincy, as I was saying, some of you here have slept off, but your eyes are still open. So shake your body if you want to. It's a nice class. I'm so sorry we are staying up to this time, but we have to. Now, I hope that one is taken care of. Now, the next one that you are likely to talk about, please go and look at those formulas again. Look at it what? Again. Before you enter the exam hall, look at it what? Again. If, for instance, you are asked to solve the solubility, and what they gave you is mass and volume in dm cube, and they say find the solubility in gram per dm cube, it's very simple. Solubility in gram per dm cube is quite simple and easy. Solubility in gram per dm cube is quite simple. S in gram per dm cube is equals mass of solutes in gram divided by volume of solvent in dm cube. Another way of finding it is equals mass in gram divided by volume in cm cube times 1,000 over 1. Oh yeah, put this down. Put these formulas down. I'm giving you straightforward formulas. You can't see anything. Are you sleeping? Eh? Not true, Seth. Yeah, so far. Okay. Okay. So the point generally is that you have gram mass in gram per volume in dm cube. Okay, that didn't work. Okay, so with that said, let's leave that part of solubility. The major one that usually comes out is this one I just gave you. Now, with that said, the other thing I think is very important we need to understand is solubility curve. But before that, solve this question. Everybody, online, offline, solve this question. I think it's important. Online, offline, solve this question. Okay. Sorry. Yeah. So, yeah. Sorry for the delay. Okay, right, everybody. 50 cm cube of a saturated solution of sugar. 50 cm cube of a saturated solution of sugar. 50 cm cube of a saturated solution of sugar. 50 cm cube of a saturated solution of sugar. Saturated solution of sugar of molar mass 342.0 gram. 50 cm cube of a saturated solution of sugar of molar mass 342.0 gram of molar mass 342.0 gram at 40 degrees Celsius. At 40 degrees Celsius was evaporated to dryness. Was evaporated to dryness. Was evaporated to dryness. Full stop. Was evaporated to dryness. You now write, if the solubility of the salt, if the solubility of the salt, sorry, did I say salt? Of the sugar. If the solubility of the sugar at 40 degrees Celsius is solubility of the sugar at waiting 40 degrees Celsius is 2 moles per dm cube. Is 2 moles per dm cube. Is 2 moles per dm cube. What is the mass of the solute? What is the mass of the solute, bracket sugar? Okay, can we solve? Everybody, you have 30 seconds to solve. Option A is 4.6 grams. Option B is 3.42 gram. Option C is 46 gram. And option D is 34.2 gram. Option A is 4.6 gram. Option B is 3.42 gram. Option C is 46 gram. And option D is 34.2 grams. What do we think? Solve, not what you think. Solve it. Please, which formula are we going to use here now? We are dealing with solubility mole per dm cube bar. Solute is a mass. Solvent is in what? Solvent is in what now? Check your solvent. What did they give it to you? Is solvent not in cm cube? Solvent is in cm cube. Solute is in mass in gram. Solvent, solute. One solute is in mass in gram. Solvent is in cm cube. Please, what formula are we going to use to find solubility? Solubility mole per dm cube is equals what? Mass over molar mass times 1,000 over volume in CMQ. So you make the mass subject of formula. Solve now. You have finished. Yes, those online, what do we have as our answer? Those here, when I don't get answer at all, what will I get? Those here, what's your answer? What do we have? 34.2 here. Online, what are we getting? Okay, so let's continue. 34.2 gram is what most of us are getting. Now let's check, how did we get that answer? Listen, how did we get that answer? How did we get that answer? We were given solubility in mole per dmq. You were asked to find mass and your volume is in CMQ. So any formula we are going to use must have solubility in mole per dmq. It must have mass in gram and must have the volume in CMQ. Solubility, 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 mole per dmq. What is it equals? What is it equals? We have mass over molar mass times 1,000 volume in CMQ. We have 2 mole per dmq. Bar is equal. Say we are looking for this mass. Please, what is the molar mass of the sugar they gave us? 342 times 1,000 divided by, what's the volume in CMQ? 50. So please, what are we supposed to do at this point? You cross multiply, right? So what is this going to be? Mass times 1,000 will be equals 2 times 342 times what? 50. If you do this, M is going to be equals 2 times 342 times 50 divided by what? 1,000. Now, let's break this down. First of all, 2 here, 1. 2 here, how many? 500. 0, 0. Then 5 here, 1. 5 here, 10. What is this going to be? 342 divided by 10, which is equals 34.2. So please put this down. 34.2. Okay. So before I think most of us are feeling sleepy. Most of us online. Should we go and sleep? If you are online and you want us to go and sleep, indicate. Those here, you want us to go and sleep, indicate. Yes, yes, yes. You want us to go and sleep. Okay, now, for those of us that are online and those of us that are physically here, we don't have 3 days again. We die here. Shall all of you say we die here when we start the class? Ha. You people were saying we die here 4 o'clock. Today is Tuesday. Sorry, is today Tuesday? Tomorrow is Wednesday. Next tomorrow is what? Thursday. And you are going to write on Friday. With this consideration, should we go and sleep? Okay, now, what if we decide to go and sleep and reschedule this to Thursday evening? Evening, it is, when I mean Thursday, you know, the glitches we had today, it will not happen again. The glitches was because of those who that did not register early. We had 100 capacity. Once 100 was into Zoom, the class was moving fluently. But we had people that were outside the class. The class became saturated at what point? 100. So because of those that came late, we needed to do something. That's why we stopped transmission and had to find other routes. Now, with that said, I think we need to reschedule. And if we are rescheduling, it is not going to be a night class. Even if it is going to be night class, it is going to start early and end before 12. What happened today will not happen again. We are sure of that. We've noticed this and we'll work towards that. Now, if you are going to be attending the Thursday class, do we agree? Those online, what do you think? Should we reschedule to Thursday? Yes, those here. What do you think? Thursday. Thursday, what time? What are they saying? Those online? Okay. So one no. Online, we have one no from Happiness. What time on Thursday? You will not get me available by anytime during the day. So it has to be from 6. So online. That's what it means. Sorry, I don't want to be teaching like sleeping human beings. Yeah. After who go watch them? These ones where they all of them don't sleep finish. No, and they watching an eye now. Time Thursday if we are rescheduling 6 to 1. Yeah, they have class. Yeah, that's true. 8 p.m. to 11. Okay, 8 p.m. to 11. That can work. 8 p.m. to 11. That can work. 7 or 8 p.m. to 11. That can work. So with all said and done, should we go and sleep? Okay. Okay, what of Wednesday? What of Wednesday? Is Wednesday okay by us? Online, Wednesday, what do we think? What if we start a class by 5 a.m.? 5 a.m. 5 a.m. on Wednesday till 8. Wednesday. Is Wednesday taken online so that we know what we're doing? Wednesday or Thursday? Eh? Okay, we are going to reschedule. Okay, we are going to stop the class at this point. So for those online, we are rescheduling. We will send the link for everybody to join and then fix the class. Please, if you are going to be part of this class, indicate interest. So that we won't have what happened today again. What actually spoiled the transmission was that we became saturated and people were complaining. That's why we had to find other means. But if you are going to be part of this class, you are going to indicate. We'll open the group. And as many of them that indicate interest, we'll have to open another group for you people. Once that group has 50 people, 50, is it too small? Okay. Once it is 100, we are locking you out. So we are going to open the group or find a system. We'll tell you that before tomorrow morning on how to indicate interest if you're going to continue the class. There will be no extra charge for those that are already online. There will be no extra charge. But if you want support ministry, if you see support ministry, but there is no extra charge. We'll have the extra class on Wednesday. Thank you very much for your time. Let's go to bed. Now the time it has to be an evening time. I'm not free during the day, any day. Wednesday, it's going to start from 7 p.m. and end by 11 p.m. at most 12. 7 p.m. and end by 11 p.m. at most 12. If you're having issues with the time, direct message me. We'll be closing at this point. Thank you very much. You can all go and sleep. Those that are live, if you want to continue the class, you go and read your book. Shut down. Wednesday. So we'll send formalities on how to join the class on Wednesday. We'll not stay past 12 on Wednesday because we'll start early. And how we are going to do it, we would have, once we have up to 100 people, we're not collecting again. Thank you very much. Have a nice day. Before you go off, hello, those online, for those that joined online for the organic class, there would be a completion of that class online, but it's a nice class. If you are interested, you holler at us, organic, completion of organic. We'll complete it online by tomorrow. Inorganic, we said Wednesday. What's tomorrow? That's what I mean is organic class will be completed this night. Yes. If you're interested in completing the organic chemistry class with us, we're going to complete the study this night. However, there's no physical class. It's online. If you're interested, you have to indicate your interest early. We are not going to accept more than 50 people into that class to avoid traffic. Because what happened today is that we planned for 100 and we got close to 160 to 100 students. So we are only planning for 50. Once it's 50, we block you. We block you. You are not going to enter. there is no extra charge paid. Thank you very much for studying with us tonight. We hope to make your learning more easier, and we wish all of you success in Jesus' name. Amen. This is Wits Lounge, where we make learning easy.
Power off.